Good morning, sir.
So whether my screen is visible to you?
Yes, sir, your screen is visible.
Okay, thank you.
Sir, I'll begin with a basic intro. Yes, introduction.
Hmm?
So I'll just begin with a basic introduction.
Okay, okay.
Good morning, everyone. After successfully completing day one of our workshop on cybersecurity and special emphasis on network security and quantum security, we are ready to proceed with day two of our workshop. We'll be starting off with our workshop in a few minutes. The workshop will be streamed in YouTube as an unlisted video. Only the registered viewers will have access to the video streaming in YouTube. The viewers will be able to put up their questions in the chat box, and we'll put the questions forward to the faculties one by one from that. Yeah, and please do submit the feedback form at the end to get the certificates. And yes, we can start. Prabita, now I hand it over to you.
Okay, today we are truly honored to have Dr. Jyoti Prakash Singh sir with us. He is an associate professor in the Department of Computer Science and Engineering, NIT Patna. He is a senior member of IEEE ACM and a life member of CSI, IE, and ISTE. He is an expert in text mining, machine learning, and deep learning. Sir has also published more than 150 papers and articles. I, on behalf of the Department of Information Technology, Guwahati University, would like to extend a very warm welcome, sir. He will be taking the workshop on malware analysis and mitigation techniques. Now, without any further delay, I would like to request Dr. Jyoti Prakash Singh sir to continue with the workshop. Over to you, sir. Thank you.
Thank you. Thank you. I think Ranjita, your name is, no? Okay, so thank you for the nice introduction and nice arrangement of this workshop. Even the videos are, as informed by your friend, that it will be streaming on YouTube channel. So that's nice. So a lot of participants will be joining. And today, so I will be discussing about malware analysis and mitigation technique. It is the idea, basically, we all are aware about the antivirus softwares. So more or less, the talk will be oriented towards that, what antivirus softwares are and how they work, and how we can, even as a student and the other experts or the other participants who will be joining here, can say basically do some more research into that and stop the malwares at the first place. So to begin with, let us start. So this is what I will be covering. So we all know what is a malware. Formally defined, a malware is a code that performs malicious actions inside any system. Basically, wherever there is a software component, we can always inject a code. Ultimately, in any software system, be it a computer, be it say any IoT device, be it a mobile device, anywhere. So wherever there is a software running, if we can inject a code which can perform a malicious action, we call that as a malware. It can take the form of an executable, so exe file on Windows platform. It can be a simple scripts, or it can be any other form of code which can just compile on that platform and run, or some other softwares. We all know that these are used by the attackers to steal sensitive information, spy on the infected system, and sometimes they take control of the system. And the other characteristic of the malware is it gets into one system without his or her consent through email, web, USB drives. We all are, in fact, the whatever information is written on the slides, we all are almost aware about this. What they can do is also known to most of us, in fact, all of us. So they can disturb the computing operations. They can steal the sensitive information. That includes the personal, business, financial data. Now you consider a mobile malware. So mobile malware can just sit onto your mobile device in any right platform, and they can include all sensitive information, your photos, your banking information, password, etc. And we have heard a lot of stories and a lot of newspaper reports on that. Say they can get the unauthorized access to the victim system. They can spy on the victims. They can send spam emails on behalf of the victim. And nowadays, the most disturbing one is distributed denial of service attacks. So earlier we had denial of service attack where a server was not able to serve basically the clients for whom it was supposed to do. Now, and in that case, say if one system, in that case, it was happening that it used to happen that one particular system or attacker is sending so many unwanted requests to that particular server. And that was easy to identify that, okay, if the requests are coming from one particular system, we can stop that. But you consider the distributed nature of this. So if we have several computers sending requests to one particular server, so they may mostly look like a legitimate request. And thereby that creates a denial of service attack, distributed denial of service attack. Nowadays, another attack is also very popular, which is called the ransom attack. So they lock your system files. So once if your system is corrupted or if your system is attacked, they can encrypt all your files onto your system, and then they will ask for a ransom. You give this amount of money to me, might be in form of any form. In fact, Bitcoin and all these digital currencies have become a very important tool in that. So they can ask for some amount of money, and if you give them the money, probably they will give you the password, and thereby you can decrypt your files and folders. Otherwise, your files, all the information in your system is gone. Types of malware, we almost all BTech and in fact, even the common people knows all these things. Viruses, so viruses are software codes, they are copying of itself and spreading to other computers. So they do not need user intervention. Worms, on the other hand, spread without, but viruses needs user interventions. And worms, on the other hand, more or less similar to virus, but they can do so without any user intervention. Trojan, which is a very popular class, still it's a very old concept, but still very popular, and a lot of Trojan attacks are occurring every day. So what a Trojan is, a Trojan disguises itself as a regular program, and it tricks the user to install on their systems. Mostly, say if you are installing a freeware like a game or a free software, a freeware software of any say paid software. So you can expect that a small amount of code is there in the backend of that particular free software, and otherwise the normal software, the intended purpose of the software will be used. So the software will be working as expected. When the background, since there is a Trojan, there is a small program, so that program can say do their malicious action by stealing the sensitive information on your system or uploading some file from your system to one command and control system. They can even monitor your webcams and capture certain pictures, etc. So another sort of, or you can say a variant of Trojans can be RAT, where the Trojans are basically a program which comes through some legitimate software. On the other hand, what attacker can do, they can create or they can look for all the open ports onto your system. So we know in our computer system, whenever there is a network communication going on, we have a lot of the communication is going on through certain ports. And some of the ports are kept open basically because the user doesn't know much about them. So what an attacker can do, and they does normally attacker do that they search for the open ports, and if a port is open, they can enter through that particular port. They can enter into your system, and they can gain access to your say computer. Sometimes they can even get your passwords also, the privileged password, root password, and then the system will be under their control, and then they can execute any command onto that particular compromised system. So if the system is on 24/7, like a small server, etc., say your web server or a mail server which is kept in your institute, so they can log into that, so they can take control of that, and when mostly the traffic is low in the night time when no one is using, they know that normal users are not using that, then they can in fact use that particular system to say create some sort of denial of service attack, or they can say use that system to attack other systems and so on. Other sort of malwares are adware, which very commonly we see in our regular system. So, several whenever you open a website or even sometimes in your system, whenever you switch on your system, several ads starts coming to your taskbar or similar to that right hand lower corner of that system. So basically, these are the ads. Although they do not do any malicious activities, but obviously they annoy the user by frequently sending those ads. Then the other type of say attacks or other type of malwares are called as botnet. So botnet, as I told that, say if a user has attacked a system and then they can say installs simple programs, a simple malicious program into several systems, and all those systems can work in sync. So there are several systems which are working in a sync through one command and control server, and then they can create some sort of say they can do synchronous work. They can attack one common system in a synchronous manner. Those are called as botnets. So botnet is nowadays a very common attack coming on. Then there are certain small information stealers, like they can steal the sensitive informations like keyloggers, spyware, snipers, and so on. So, like you are typing something, and then there is a small program sitting inside your computer, and that is just trying to see what key you are pressing, and based on that, they can say guess your passwords or your banking password, etc. Ransomware, I have already told that they can lock your system, basically encrypt your files, and then ask for some money. Then there are certain rootkits. So they provide the attacker with privileged access to the infected system. So it's like that only. But if the along with that access to a system, if we have got the privileged users account information or account privilege, then you can that system can be that is defined as a rootkit attack. Then downloader, we frequently see this that whenever we download a program, then other softwares also ask for that this can be installed or this needs to be installed. So those are basically called as downloader or dropper. Now there are several categories I told, starting from this viruses to botnets to information logger to keylogger to downloader and so on. So that they are simple classification and they may vary from one author to author, another author, one book to another book. It is not possible to classify all the malwares based on their functionalities only, because sometimes a single malware can do multiple functionalities. Like you can have a worm which comes to your system and then it drops a ransomware. So it is both. It is a worm which drops a ransomware. So it is a worm, it is a dropper, and then finally a ransomware. So we can have a combination of this. So the purpose of the whole purpose of saying classifying this way was just to give information. We have this sort of malwares. Now, as I told that in this particular lecture, I am not going to just give you a basic idea of what a malware, or basically what malware is, or what dropper are, and all these things are. My idea or my main thrust in this particular talk is how to identify these malwares, right? How to identify these malware means how those antivirus softwares, what we talk about, all these antivirus softwares, what they do, and how we can really, even without antivirus software, you can check your system time to time. And if you want to do some research, if you want to do some sort of more robust techniques, which can, because any antivirus cannot detect all possible malwares. So if you want to add something, if you have, say, if you are really into that, and if you find out some way by which you can really enhance this area by doing some sort of more work into that, that's the idea. So for that, we analyze the malware. Now, what is the analysis of malware? So we study the malware's behavior in order to understand the working of that particular malware. And by understanding the behavior of the malware and working of that malware, we can detect it, eliminate it. So given, now what happens? As I told, a malware is basically a software. So given a binary file on your system, so if you know nothing about that binary file, or if you think that, okay, this binary, why this binary file is in my system? You consider a scenario that you are sitting on your system and then suddenly you saw that there is a binary file, but this binary file is not a normal user by normal say Windows binary file, or neither it has been created by me. Then probably that's a suspect to me. So analyze that suspect in a safe environment to identify its characteristic and functionalities. So if you analyze that suspect, so if you look into that suspect, okay, how that suspect is behaving, what are the properties of that suspect, and if you come with certain features which you feel that these features are normally found in a malware, then probably you can label that particular binary file as a malware. So that's the idea of analyzing a malware. By analyzing a malware, we can determine the nature and purpose of that one. It can help you to determine whether a malware is an information stealer, HTTP bot, spam bot, rootkit, keylogger, rat, and so on. We can also gain an understanding of how the system was compromised and its impact. So if we analyze the malware, then we'll also come to know that from where these things came into our network and how much impact it has done into my network. So what are the things which have been basically disturbed by this? And if there is any variance, because if it is a dropper or if it is some sort of worm, then it might have affected some more systems. So what is the impact? How many systems have been infected? What to do in order to regain, so basically restore the system to its earlier stage and so on. So malware analysis also finds out or helps us to, or how they are done. Basically, we can identify certain network indicators associated with the malware, which can be used to detect similar infections using network monitoring. So you analyze or you know that from your earlier experience that if something is coming from this IP address, then probably this can be a malware. Or this IP is not a very good one, this IP is blocked, but somehow you have a file in your system, a suspect binary file in your system, and that binary file is sending something to that IP address. So by analyzing that malware, you can find out that IP address, and if you can find out that, then you can say that probably this is a malware, which is basically some sort of Trojan or rat sort of things, which is communicating with this IP. You can also find out during analysis, you can also find out certain host-based indicators like file names and registry keys, which can show you or which can determine similar infections. Like you know that a malware creates a registry key. So earlier also we had a malware which has done something or written something into the registry key. So if a new program or new binary is also writing similar things in registry, then you can understand, okay, this is also some sort of suspect and malicious program, it can do this. So you can use this registry key as an indicator to create a signature and scan your network to identify all the hosts that have the same registry key. The analysis also helps determine the attacker's intention and motive. If you find that the malware is stealing banking information, banking credentials, then you can decode that the motive of the attacker is monetary gain. But if you find that they are just trying to disturb the system, then probably you know that they are into something else. So threat intelligence teams often use these indicators determined from a malware analysis to classify the attack and attribute them to the known threats. And malware analysis can help you get information about who could be behind the attack also. Like, is it a competitor of which is similar nature, working in the similar domain like you, or is it a state-sponsored attack? So is it a different country who is attacking on into a country and so on? So analysis can also help into that. So that's why malware analysis is a very important thing to do. Now, how we can now? I have told that, okay, malwares, and then we can analyze the malwares, and malware analysis can unfold several things to us. Now, the question is how to do this analysis. So, basically, we have two different types of analysis techniques. The first one is called as static analysis technique. Static analysis technique. In static analysis, it is basically we are not executing the binary. So we have a binary. Say if you have something, say if I say that, okay, say this pane is my suspect. So I have this suspect. I'm not executing it. I'm not opening and writing something using this pane. But instead, I am just looking into this pane and I'm trying to associate, trying to find out certain features from this. Okay, what are the features of this pane? So, and based on those features, we want to classify that, or we want to deduce that whether it is really a malware or not. So, in static analysis, we perform, we do not perform any, basically, we do not execute it. It is, so that's why it is very easy to perform. We only extract the metadata associated with the suspect binary. I will be just shortly coming to this, what informations we can extract, what features I can extract from this sort of suspected binary. Sometimes it also provides interesting information to focus your subsequent analysis efforts. Like sometimes simple static analysis can give us certain ideas or certain details which may help us to do more focused dynamic analysis. Static analysis can also give me whether it is it has certain IP addresses associated with that malware, and so we can also use write certain rules in my network traffic so that all the traffic from that network can be stopped and so on. On the other hand, the other analysis technique is called as dynamic analysis technique or behavioral analysis. In dynamic analysis, we create a sandbox environment. Basically, we create a virtual system. And in that virtual isolated environment, we execute that binary. So we run that particular binary. So if it is a Windows binary, just double click on that and it will start executing. If it is, when it is executing, then you can you can note down certain parameters. Like while it is executing, you can note down if it is communicating with the network outside environment. So is it sending some data to the network? Is it writing something into the registry? Is it deleting some file? Is it encrypting some file? And so on. So all those informations you can write during that say execution into that safe platform. And then based on that, you can write a program. Or basically you can create a signature or you can write a machine learning based program, which in future, if a new malware is coming, you can say reduce those features again and you can just classify that whether it's a malware or not. And if it is a malware, what sort of malware, what is the family of that malware. The other analysis technique people have come up, so these are basically two analysis techniques, static and dynamic. But people also, a lot of time, people also do code analysis. Ultimately, a binary file basically is written into certain programming languages, might be say Java, or might be C, or might be some sort of VB++ and so on. So if I can get that code, or if I can even get some sort of assembly code, then probably we can analyze that code line by line and we can better understand what that malware is doing. So in code analysis, we focus on analyzing the code to understand the inner working of the binary. And this technique reveals information that is not possible to determine just from any static or dynamic analysis. Even in code analysis, we can have two ways. One is static code analysis. So we just reverse engineer it. So given a code or given a suspect binary, so we know that binary file is in terms of 0 and 1. So first we disassemble it to get certain assembly language code. And then from that assembly language code, we get some high level code also. There are softwares to do all these things. And in this talk, I will also introduce you, I'll give you some software, even some, I will run and I will show you that how these softwares work. While in dynamic analysis, in dynamic code analysis, what we do, we again reverse engineer it and then we run that. So in static code analysis, we manually check the code, whereas in dynamic code analysis, we use a debugger to debug that code suspected binary in a control environment and see what it is working. Obviously, doing this code analysis requires a very good understanding of obviously the architecture of the machine, the programming languages, and the operating system concepts. Last, but in fact, this is not sort of, sometimes people call it as forensic also, but I put it in analysis techniques only. and that is called as memory analysis technique. Now, memory analysis technique, what is unique about some viruses or some malwares are, they come to your system. So normally, with all these techniques, so whether it is code analysis, whether it is dynamic analysis or static analysis, we have this promise that this binary file is there into my hard disk, because something has been downloaded or something has come through my email or something has come through my USB stick, and they are residing on my disk space. So we have an entity which is on my disk space, and we are looking into that entity, whether it's a static analysis, then we are executing it in a dynamic analysis, and then we are reverse engineering it in case of code analysis. But malware developers are also very smart. Sometimes what they do, a program comes to your system, a malware comes to your system, they start executing it and then delete itself. Okay, I hope what I am trying to say is clear. So malware has been dropped into your system somehow, might be through email or might be through USB stick or might be some other way. It has come to your desk, and then somehow it started executing. You mistakenly you double click it on or something like that. So it started executing. As soon as it starts executing, what it does, it deletes itself. So now there is no trace on the disk space. So you cannot check or you cannot find any trace of that particular malware on your disk. So all these three techniques fail. So you can't do a static analysis of something which is not there. It is now there in the RAM, it's running in state, but there is nothing, no existence onto the disk. And since there is no existence onto the disk, you can't do any static analysis. Neither you can do dynamic analysis nor you can do code analysis. So then what we can do, and we know that if a program is running, so program is running means it is into the memory, it is taking certain memory space. So basically, you recall your concepts from that process concepts in operating system classes. So we have a process which is running into the memory. It has got a process control block. It has got certain memory space associated with that. Probably it can open a file. It can write something onto that file and so on. So it can create another process by fork and so on. So it can create a lot of other processes also. So not only a single process, but might be it has created a chain of processes inside your RAM, and they are executing. But there is no trace onto your disk. So you can't do the other analysis technique. So then we do a memory analysis technique. So might be if you have worked or if you have noticed the working of the antivirus softwares, you might have seen that sometimes the antivirus software also says that analyzing memory or analyzing RAM memory. So that's what they do. So what they do in that case, what you can do. So you have a RAM which is working. So you cannot analyze RAM when it is working. So what you do, you can take a snapshot of the RAM. So you take a snapshot of the RAM, you store it onto a disk, and then you analyze the RAM. Is there any process which looks, say, dangerous or which looks, say, which is say, suspected, which is not expected to be running in this particular time? How to do that? So you can say that if every process in Windows or in even any operating system, they have a parent inside that, and they have a sequence numbering how they are coming, and so one way is you can check the parent. If the process has a parent, legal parent into that parent tree, that process tree, then probably it's okay. Otherwise, this is a suspect. And there are several other measures. There are several other softwares which I will again just give certain snapshot and certain names of those softwares. If you want, you can use those software on your system and you can check it. So this is how we analyze it. So as I told, that the first analysis techniques is the static analysis technique. So in static analysis, what we do, we fingerprint the malware. Now, a very novice user, say just a beginner, which starts writing a malware, which starts developing malware and want to disturb to the system just for fun. So first step, what they do is normally they just rename the malware and then again send it to some other system. So you have one malware which has got several names now and coming through several different ways. So by name, by file name itself, you cannot identify a malware. So what what is the first step is we fingerprint the malware. Now fingerprinting means we create a hash code of the malware. So given the whole exe file, we use any hashing technique like SHA, SHA-256 or say other hash techniques. So any hash technique you can apply, cryptographic hash, and the cryptographic hash will give you a fixed length string for that. And that fixed length string becomes the name of that particular malware. It follows after 12. Okay, so that is called as fingerprinting the malware. Once you have fingerprinted the malware, that means once you have created the hash of that malware and renamed it, means the hash becomes the name of the malware, then you know that whenever you are creating or you are getting say different malwares from different sources, and if they are same malware having different names, once you create the hash, you will have the same name, same hash value. You can compare them and you can easily say that since this hash value is a malware, so these are the malwares. So you can, in fact, remove some of them. The next one is identifying the malware's target architecture. So whether you have given now a suspect, you have got a suspect. Now the next question is whether that suspect is really which is going to run on a Windows platform or on a Linux platform or on an Android platform or x86 architecture or any other architecture, some Spark architecture. So which architecture it is going to run? So that's the second thing we do in case of static analysis. Next is we scan the suspected binary with antivirus engines. So now we do not need to buy antivirus engine. In fact, we have, I will show you just on website, we have a website of antivirus engines. So this hash code, what I just created, that fingerprint. So that fingerprint you can submit to that antivirus engine, and then the antivirus engine will give you that whether it is a virus program or antivirus, means virus or not, malware or not. Then the next step is we extract strings. So given that suspect, we extract the strings. Even in an exe file, now you just think over it. Even in an exe file, if you have given, like you write a program like hello world. So whenever you write a hello world program and you compile it to .exe, basically everything is converted to machine code. But this hello world is only converted to ASCII codes because this is a string. So either ASCII or Unicode, whatever you are using, it normally goes to that ASCII code. So given a exe file which is in 01 format, you can easily find out how many ASCII characters are there or Unicode characters are there. And we call all those ASCII or Unicode characters as strings. And we can extract all possible strings from a binary file without running it, without executing it. Similarly, we can stack the function names and other metadata which are associated with the file. Now, how these strings can help? In fact, strings help in a lot of ways because strings, so like if your malware is going to communicate with the IP address, so outside IP address, then the IP address is basically a string. If it is say a downloader, then probably there will be certain commands or there is something like you download something from this website because the program which will be downloaded is obviously there on the website, some website. So some website information you will get. So all this will be in the form of strings. Sometimes the password or even the encryption keys, etc., also might be in string. If the malware developer is not a very expert one, they can also write it there, hard code there. So that also you can get. So by extracting strings, we can get all those things. Then the next one is even the malware developers are so becoming very smart. In fact, they are more smarter than normal common people. So what they do, because we can extract strings, because we can say identify the architecture, etc., they developed something called as obfuscation technique. Now, what is obfuscation technique? Obfuscation technique is basically given a binary code. So you have heard of cryptography. We all know cryptography, or we all know compression techniques. So consider we have a binary file. That means you have created an exe file of a malware. And so that exe file will be some sort of 01 sequence. So you have 01 sequence. And then now you do a cryptography on that. So you just use an encryption scheme on that. So if you perform an encryption onto that, what happens? The whole values will change. The values will be replaced by some other values. And even the strings, the function names, etc., that you cannot now directly get. So if you do the string analysis, etc., because that has changed. So if you get something, that will be in a different format. So that will give you a different strings. So this is one way, and the other way is called as the compression way. So we can compress. So if, because one of the target of any malware developer is we need to send this malware through certain channels, like mostly network channels, and so the size of the malware should be as small as possible. So for that they need to compress their data, and so that exe file, once that exe file is ready, they can use some sort of compression technique, and then they can compress it. So if they compress it, the whole structure of the binary changes. So in a compressed binary, if you try to find out the strings and everything else, that will be different. So the other step in a static analysis can be to identify that whether it is obfuscated, or basically we call it as backed or encrypted. If it is so, then can we decrypt it? Can we decompress it? Sometimes, in fact, we can do it easily. So, because if the compression technique or if the say encryption technique is a known one, easier one, you can easily convert it or you can easily decompress it. But if it is an advanced version or some new encryption technique, or say some different encryption technique which is not very common, then probably that will take another step. So you need to really reverse engineer and use very sophisticated technique to get rid of that. And lastly, obviously, we can, once we have these things, then we can classify, and by comparing the different features what we get from this static analysis. So this is again the same thing. So ID assignment is basically that fingerprinting, what I told. We call it as ID assignment, then file type identification, then antivirus detection. So we just need to check that whether it is really what other antivirus system says. And then we need to identify this protective mechanism, that is obfuscation technique. And then I will be now coming to this PE structure, string analysis, static code analysis. So this is the way we assign ID. So it is a unique identifier to the file. A common practice is to use hash. We can have MD5 or SAR1 or SAR2. And if we have hash collisions, two different input produces the same, then we know that they are the same file. So we have, in fact, say this is a program. So if you have something, if you are working on a Linux system, you can use this sort of code. So on Linux, we have directly command MD5 sum, and then you give a file name, you will get a corresponding hash for that. On say SAR20 Linux, we have, if you want to create SAR hash, then SAR256 sum, and the name of file name of that suspected binary, you will get that some sorry, the cryptographic hash. Similarly for SAR1 hash and so on. On Windows, you can download a software called as HashMyFile, and there are several others. This is not the only one, but if you want, you can go to this HashMyFiles. You can see, so this is the website. You can easily find out here the HashMyFile, and just if you give, you will get the hash code of that. Okay. Or if you want to write a program, say if you want that, okay, now I will develop, say I'm going to do research in this one, and for that I need to develop a automated tool, or basically a program which can create or which can give me the hash. Then you can even write a simple Python program. So this is a simple Python script. You can see there is a library called as hashlib in Python. So you can first pip install if it is not there on your system. So you can pip install hashlib. If it is already on your system, then you import it, then open a file. So this log.exe is that suspected binary file. We open it in read mode, read mode. We read it, and then we create save. So we have this hashlib.md5 content. Content is this file. .hex digest will give you the MD5, then has let's say SAR256 will give you SAR256, and then SAR1 will give you SAR1. So given a file, you can easily create and get the ID, or basically the finger. You can do the fingerprint. Then the next type is the next step is, once you have the fingerprint, the next step, which is so very needed and very important, is to identify the file type and architecture on which this will work, this will attack. Like whether the operating system on which it is going to attack is Windows, Linux, Mac, whatever. What is the architecture? This is mostly being, it will be more destructive, whether it is 32-bit or 64-bit. So on Windows platform, we call a file as portable executable file. So all the files will execute on a Windows platform. They are called as a portable executable PE file. Again, I am repeating, portable executable or PE file. And this includes .exe, .dll, .sys, .drb, .com, .ocx, and so on. So if you have any one of these extensions, you can think that they are targeted for Windows. So given a file, so say if I say that I have a file and whose extension is .exe, then obviously this is going to execute on a Windows platform. But here also the malware developers basically play certain trick. They create some, they do some trick onto that. So what they do, they have a file which is basically exe, but they can add an icon of say PDF. So and if you see most of the Windows, say like now the current version of Windows, like see here, you hardly can see the extensions. Here, although I can easily disable it, if I remove it, I cannot see the extensions most of the time. Like this is a common file type and you can't see any extension associated with this. You can't see any extension associated with this. With some you can see extension. So with this you can see extension, but with this you cannot see extension. So if it is a common file type like .pdf, you can't see an extension of that. So this is what malware developers, you can see extension if you want, if you just add that feature or say switch on that feature in Windows. I think you can switch on the feature from this place, like in view, and then so file name extension, then now it shows. But by default, most of the time it is normally it is say not showing, so they are off. So now, so they take advantage of that, and it will look to you that it is a PDF file, but basically it is an exe file because you can't see the extension. So you will get something .pdf.exe. Say if I write, say let me just show you the trick what they do. So say I have a Windows System 32. Let me just open a calculator. If it is here, Windows speech code. Okay. Sorry, I have deleted all those things. Let me just show you. Calculator. So I can just take a calculator program and then add I can change the icon of that program to say a PDF, and then I can give an extension .pdf.exe. Okay. So to a normal user, it will seem that it is basically a calculator program, but in the background, basically, I will just wait. Let it search. Like in the background, it is basically a executable file. So that's why we need to find out, even any suspect, we need to find out what type of file is. So merely looking, visual information is not sufficient in this case. So as I told, Windows-based malware are executable ending with this. So not recommended. The reason I told, because attackers use different tricks to hide their files by modifying the file extension and changing its appearance to trick users into executing it. But file signature can be used to determine the file type. Now, what is file signature? You can see here. So let me just find out that. So this is the calculator program. So let me just put my calculator program here. So this calculator program, if I write it something like this, say rename calculator dot pdf, and then I can change the icon also. Details, original file names. Okay, I think I'm just not recalling it exactly how to, but you can see now, if you see, it is cal.pdf, and if I can change the icon, which somehow I'm not recalling it how to do it, but that can be easily done. That can be easily done. Then you can see that it looks like a PDF. It may look like a PDF program. Okay. So let me show you something else which I was more interested right now. So say I have a software here called as PE internals. You can see this software PE internal, and then in that PE internal, I'm just showing you something. Although in first instance it may look like very hazy to you. What is this? Not getting anything. Don't worry. Just have a look at this. So what you can see here is, you can see here the first word is MZ here, and this is 4D 5A. Then you can see this is a program cannot be run in DOS mode. Then here text, data. If you continue, if you go on, down, you will get something. Some sort of response. So this hello world, where is hello world, I think. So you get here GNU, etc. So this is a C program. So this is a C program. So this is a string. I will just show you the program also. This is a C program, and then this was executed through GCC and GNU compiler. All those informations are shown. So, and this file, in fact, this is showing the binary of this one, demo analysis. Okay. So this demo analysis is basically that exe file whose internals or whose details I am able to see into this one. So this is the code. In fact, if you see, so this part, this exe4d5a 90.000.30.000, this is what is written inside this particular file, demo analysis. This demo analysis was a simple program. I think this was the program I had written. So this was the program, and that was compiled into that demo analysis. This demo analysis is a compiled version of this program. Okay. I hope. Are you there? Participants are still there or not?
Yes, sir, they are there.
So, are you really getting it? Yes, no, no.
Yes, sir. Yes, sir.
So basically what I had done is, in order to just explain you exactly what is a binary, when I have just this C program. Everyone understand the C program. So this is a very simple C program. The only thing it will be doing is it will basically print this message. This is a C program. I compiled it. I got this demo.analysis. And then this demo.analysis, we know that if a program is compiled, it gets converted into a binary file that all of you have heard so many times. Now it is inside your blood that if it is compiled, it will give you a binary file. Fine. But what is there in that binary file? So this is what I am showing. Sorry. This is what I am showing here. So this is what is there inside that binary file if it is for Windows platform. Remember that it is not true that this binary file will give this only for all platform. No, this is for Windows platform only. So if you compile it for a Windows platform, you will get this, right? And how to identify that this is for a Windows platform? So this highlighted bit, so 4D 5A, if the first bit is 4D 5A or MZ here, we say that this particular file, whether whatever file it is, this demo.analysis is a file which is going to be executed on a Windows platform. The operating system is Windows on which it will run. That's clear. So from these two words, so that's the magic information we get. Good. Now, so this is what was there in this slide. So you can see in this slide also you have similar thing. So this is not, obviously this was taken from a book, so this is not something I have developed. So you can see here, this is 4D, 5A, MC, just like what my program was showing. So what you get a unique sequence of byte that is written to the file header. And the executive Windows executable files have MZ or hexadecimal character 4D, 5A in the first 2 bytes of the file. So if you get this information, so first thing, key on which operating system it is going to run is clear that this is for Windows. Okay. So this is one way. So I have just used a code or basically a simple program software for finding out this. If you want to know, I will see it manually. So there are other things like hex editors, like HXD hex editor, or in Unix you can just type this XXD minus G1 and then the name of that suspect binary, you will get every information. Even you can write a simple Python program. So if you want that, okay, no, I do not want all these informations, all these details. I just want that whether it is for Windows platform or not. Then you can just check that file type. So you can write a program. And for that, you need a package called as magic. So first you pip install magic if it is not there, or if it is there, then import magic, then magic open, magic load, and then file type. So m.file and the name of the file. And then you will get file type. So if you run this, it will give you basically the type of file is this. So Windows platform and so on. So that is one way you can get. Then, so now we have even whatever file information you get, whatever binary you get, by opening it in this sort of P internals, means the software. The name of the software was basically P internal. There are several such softwares. Mind it. And a number of softwares are there for this purpose, and it is up to you what you prefer. There are PEBR, which is again a very good software, then P internal, then hex editor, simple hex editor without any specific purpose, and then you can do this. Or if you are not very good in that, if you want that I'm very good in Python, I would like to write a code for that, you can write this code. You can try this course. So once we have determined that, we can go to these two virus sites. So you can see here, this is a site, virus total. So you have this website, virus total, and in this particular website, you can upload your program. So say I have this, all of you know that this is not an antivirus as a virus, because the problem of working with this Windows platform is I can't really keep a virus program here and show you. So I'm sorry that I utilize the Windows system to just explain these ideas, but uh, I must have taken a Linux platform. So what you can do, you can, again, as I told, you can do a fingerprint. So you can do the hashing, and then those hash files you can upload from this. Or even you can upload the exe file. So I can go to desktop, and you can see this exe. You can see that it is checking, and then it will give you something like this. So you see that uh, these are all antivirus softwares available across the world, like Acronis, Alab, Alvac, Arcad, Avira, Bitdefender. Some of you might have heard the name of some of them, like Bitdefender, BCAP Pro, Komodo, Cyberizon, Cynet, Dr. Wave, Emisoft, SNet, Fronted, Google, K7, Kaspersky, and McAfee, Microsoft, Quick so some of them are known to you, some of them might not be known to you. Trend Micro, these are also available in Symantec. So you see that, and then these are also. It's not only this. So there are around number of software. I think around 64 softwares available. 64, 65. Baidu, Adware, Alibaba. So all of them have their own antivirus engines, and this particular exe file is checked by all the engines. And you will be surprised to know if you have really a virus, all of them shows undetected. You see that 4 of them, in fact, were unable to process the file type. So they cannot process it. They could not process it. If you have really a suspected binary file, you will see that some of them will say that this is a virus, some of them will say that this is not a virus, so undetected. You will be surprised to know that you take any virus, any new virus, you submit it there. So some of them might be around 50, say 51, 52 are saying that this is a virus, but rest 10, 12 are saying that this is not a virus. This is okay, this is undetected. So now it should be quite clear to you that if you ask me, sir, whether this antivirus is good, answer is up to you only. So you have the world's all antivirus engines at one go. You can check your things, and then you can decide which one is the best one. But obviously, this I'm not showing this software or this web page just to decide which software is good or bad, because all of them have their certain strength and certain weaknesses. So some file might be caught by one, but might be say escaped by some other antivirus engines. And that's where we need to do more research. We need to come up, because most of these antivirus engines are basically signature based. That means they have certain rules, and based on that rules, they detect. But nowadays, more and more people and more and data are coming, and people are thinking of and are basically going to the machine learning techniques. So a number of machine learning techniques can be developed for this one. Okay, so that is one where you can go. There is the other one is virusscan.org. You can use these two websites to analyze any suspect file you have, or if you want to do some research in viruses, then you can download the virus files from this place. They have APIs also. In fact, I've got some programs. I do not know whether in just next couple of around 20-25 minutes I will be able to explain, but these are the programs you can check here. Like this is a code from where, so I have a file name here, and I can run this file basically on this antivirus engine. So let me just show you. So, virus malware code. Then Python. So now you see here. So I had a program that was basically a virus. So now you see here the results. I hope you can see the results. So this hash code was the hash code which I just passed here. You can see in the code. So this is a hash code which is basically a virus hash code which I have created. We have for demonstration. So you see here that this engine ALYSC, you can see here all these engines were present. ALYSC. So ALYSC. For this file it shows undetected. For this you see here it shows this is a Trojan. Okay. You see that Apex shows nothing. So basically nothing, no comment on this one. Then this says other malware. Trojan also, it also highlights it as malware. This says no, this says Trojan, this says downloader. So you see the results. Some of them says no, some of them says no, some of them shows malware. So you see, some of them says undetected, say undetected, say category malicious. So undetected, say this one. CMC says undetected for the same file. Whereas ClamAV says it is malicious. Komodo says it is malicious. CrowdStrike says not supported, so I can't say anything. It says not supported, I can't say anything. It says malicious. Signet says malicious, not supported. This says again this F-Secure. This is again a very good antivirus engine. It says undetected. That means this is not a virus. But we know that this hash code which I have passed here is a virus. We have checked in our program in our system, and this is a virus by dynamic analysis. So, in a nutshell, what I'm trying to say is, although this course may look very naively exactly what is the reason, so I know already about antiviruses, but you can see, so they are inconsistent. So even the virus total programs, they are inconsistent. So if you have a suspect and if you want to really see, you can take it from say majority voting. People normally do majority voting for that. But normally you don't share binary files to public forums, so that's why you create a hash code. Why you do not share? You are not suggested to share your binary file outside your organization is your binary. So sometimes you may not be aware, but your binary may contain some sensitive information, which might be personal or proprietary information specific to organizations. So it's better search the existing database scan file using cryptography hash. And normally the scan results of binary are stored in the public databases, so attackers can use these features later on to check whether this binary are so. And if it is undetected, the attackers may change their tactics to avoid detections. So this is the program I just executed. Then the next thing what we can do is we can extract strings, as I told. So strings are ASCII or Unicode printable sequence of character embedded in a file. They give clues about the functionality and indicators associated with the suspect binary. If a malware creates a file, the file name is stored. As I told that if it is a dropper or if it is creating another program, then that program name should be there somewhere there in the malware code as a file name. So by extracting all the strings from the malware, you can get those file names. If a malware resolves a domain name controlled by attacker, then the domain name should be stored as a string. Strings extracted from binary can contain the file names, URL, domain names, IP address, attack commands, registry keys, and so on. So one very important phase of static analysis, what all these malware engines are doing is they're extracting the strings, and based on that string, they create one level of basically you can say information. Then as I told, protective, so there are two ways. Either we can encrypt them, so we call them as cryptors, or basically we can pack them or compress them, we call them as packers. So there are two things, and there are certain common packers like Armadillo, AcePack, AceProtect 32, 3064, PE Compact, UPX. Again, you can write a program, a simple program, like a simple Python program to check, given a binary file, whether it is packed or not. So it shows you, but remember, if it doesn't show anything, that never says that this is unpacked. So it might be the system is not able to get that information in userdb.txt, and hence it is not able to say anything about that. And one more thing, even if you identify that okay, this file is packed, so just identifying that this is a packed is half battle done, means only half of the battle only, because then you need to unpack it. So unpacking is the challenging one. If it is a common packer, as I told, then you can use this sort of tools, PE Explorer, and then they support the unpacking of UPX, UPack, and SPack. And for uncommon unpackers, you can visit to this site woodman.com, crackspackers.com, and even if it is not possible to uncompress or basically decrypt through this tools whatever available here, then the best thing is do reverse engineering. Okay, so I'm just keeping this PE history. In fact, these are just let me give you a very basic idea about the PE. So you might have seen this PE information. So see this PE information. You can see here. So there are certain DOS header, then MS-DOS stub, then empty header, then signature, file header, optional header, and then certain sections. Then text, data, R data, P data, X data, BSSI data, and then certain sections like this, and then again section.text. Section, so these are section header basically, and these are the section data which is available and which are written here. So these many sections are there. Right. So what is the meaning of those things? So basically a PE format was, as I told, that was developed by Windows. So the first part contains the DOS header, then it is PE header, then certain optional header, then section headers, and then really the text section. So this text section, so what you see here, this is basically the code fragments, whatever you have developed. So all those binary codes, when we say that we have written that has include this main and so on. So the binary of that is this, the binary of this program code is stored in this section.txt data. Right? Then you have idata.section. So sorry. Then you have idata section. You know that in order to run this program, you need to import certain library functions like printf, scanf, and so many other library functions. So all those library functions, basically you are importing the codes for those binary libraries also. So all those are kept in this idata. So here you see that idata, in fact there is only there is the idata. So in idata you have, so this code, all these informations are regarding those libraries which are attached with this particular program. Then you have the resources section. So if you have strings or images, so data resources, there is no resource section as such. Yeah, sorry, this one. This is the resource section in this particular program. So this is written as R data. In some cases, you will also find that they are written as .rs, .rs or C. Here it is R data. So in R data, you see all these strings. So the string what was there in our program was, sorry, this is a C program. So this string is written here, you can see. So R data contains the strings, the images, and everything else, whatever we are writing into the program is basically stored in this R data section. Then we have relocation. So if this program has to be relocated from one location to another, so all those informations goes into that relocation sections. Then there are X data, R data, P data. So depending on P, if there is any data, extra data we are using, and all those things. So, and then there are certain sections which are not numbered. So depending on the length of the program, several sections are created. These sections are only for human readable format. Okay. only for human readable format. So that's why the name keeps changing. So with the different software, you will see that the idea is mostly that, okay, there is a DOS header, these are fixed, empty header, signature, these headers are fixed. Rest of the things are variable, so they can change at any time. So this is what is there. I will share this PDF file, sorry, this presentation file, so you can go through this if needed. So this is, you can say, in a color format. So we have the DOS header, then DOS stub, then PE header, and then we have the signature, file header, then optional header, and then the data directory. And then the section table starts from this one. Based on the string analysis, what we can do, we can use certain YARA rules. People call it as YARA rules. This is again a very powerful malware identification and classification technique. If you want to go need the details of this YARA rules, you can go to this virustotal.github.io/YARA. So YARA is basically a rule based on textual and binary information, and it consists of a set of strings and a Boolean expression which determine its logic. So use these rules to scan files using YARA utility. There is also a Python version of this called as YARA Python, which can help you to write rules into that. YARA rule basically consists of three parts. One is called as the rule identifier. So it creates a name for the rule. So it can be any alphanumeric character and underscore, but the first character can't be a digit. It is case sensitive and can't exceed 128 character. And this consists of the rules consist of a set of strings and Boolean expressions. The string definition, it can be omitted if the rule does not have any strings, or if it has a string, then it has to be started with a $sign followed by the sequence of alphanumeric character. Let's see one example. So this is a YARA rule. Based on the strings, we are trying to find out, we are trying to develop a rule in our network system, the main system which is communicating with the outside world, that if there is a string in a binary program, binary file which is coming to our system, sync flooding, or say port scanner, keylogger, then the condition is if A or B or C, that if any one of these keywords are appearing in a program, then that particular binary program may be flagged as a suspected binary or malware. You can write some more rules like this. You can add some more strings here. So that's why string analysis becomes very important. So, and these are static analysis based. So till now I have only talked about the static analysis. Then dynamic analysis, as I told, so dynamic analysis, we will not be going into that. The rest of the things, there are some things which I think you should know in order to mitigate the malwares in your day-to-day activities. So I think all of you know about the registry keys. And one of the technique which a malware does, malware uses, is called as the persistence technique. So that means if a malware has come to a system, say you think from the perspective of malware developers, they have developed a malware and somehow they have sent that malware to your system. And then you analyze that system, or you analyze that and you deleted that. Or basically it was working or it was running in your system. Then you switched on the system in the evening. Next morning you start the system, but until unless you again execute that particular program, that program is not going to run. So what malware developer does, they create persistence. That means they create some way by which that their malware can also be executed automatically. So this is called as the malware persistence techniques. So keeping the malicious program stay on compromised computer even when the system restarts is called persistence. There are several ways. One way is if you put the malware information in a registry key, then you can do so. So how to do that? The malware that is added to the run registry key gets executed at system startup. So you have a CKU. So let me just show you registry. You can read a bit. This is the command regedit, edit, sorry. So if you open, you get something like this. So this is Windows registry. I hope it is visible to you.
Yes, sir. I can take it.
So this is registry information, and you can see here what I have written HKCU. So there is something called as HK local machine. So you see here. So this is the overall structure. So this is the first level. This is they call it Microsoft call it as registry hive. They are call it as this is a database which is in a hive structure. So HK local machine. So this is HK local machine. So this was HKCU. HKCU is this one current user. HKCU. The abbreviation is for that. HKCU basically H key current user. Now in H key current user, you see that next thing is software. So you can go to this software. So you see there are so many software into this installed or registered under this particular user. Then you have Microsoft Windows current version. Then you have Microsoft, you see here, and then Windows. Yes, Windows, and then you see current version. So you see here, and then inside that you have a run. Sorry, you have run. So you have run. So these are the information. So you see here what are the programs listed in my system. Create the size. Control C plus. No, somehow I'm not able to increase the size. So you see that there is a default. Then Cisco Meeting daemon, then Cisco Spark, Teams, Microsoft Teams, then Google Driver, Grammarly, Microsoft Edge, OneDrive, PT One Click. I do not know what is this one. This is again WebEx basically. So these are the programs which are set here, and they, whenever I restart the system, so you might have noticed that whenever you restart a system, several programs starts executing that. So these are the programs which will be executed at the startup. So whenever I will restart my system, this program will start executing. Means they will, while booting, after the booting phase is over, the OS is installed, these programs will start running. And so that's why they take some time before the system becomes stable and usable. This is one location. Then there is another location, HKLM, so local user. So this is one location. Sorry, this is the current user. Then there is in local machine also you have similar structure. You see here software, Microsoft Windows current version run. So there also you can put some software. You can check in my system if there is something. On your system you can check. So software, Windows current version. I hope it is okay. Software, Microsoft Windows, software, no. Sorry, Microsoft, then Windows, then current version, and then run. So here you can see that this Epson printer, box software, and then this RTK, all these services, health system, health, security, health, all these services are registered there, and say they also execute at the startup. So whenever I'm restarting my system, they all will run. So everything listed here is basically the programs which will start at the runtime. So now you see here that one software is shown here. So you see here two parts are there. So there is our name and there is a location from where this program will run. So this C program files, Epson software, Epson printer connection, this. So this is the name of this one and this is the program which will execute. So here you can see that one malicious software has put something like this: HKLM software, Microsoft Windows current version, Policies Explorer run, printer security layer equals to this. So it looks like that it is a printer basically, and it is stored in C Windows lsprint.exe. But this is basically a virus, and what this virus does, every time you are restarting the system. At system reboot, this will start working, and this will start executing. So this is a very common technique. So all of you can say after this lecture, I will request that those who are having any suspect or any problem with their system, system getting slowed down, you can check all these registry keys, and if you find anything which is looking suspicious to you, you can check the wave and delete them. Then this is one way, by writing something in the registry key. The other way is scheduled tasks. So you can start the malicious program at a specific time and during the startup. So you have some utilities called as SCH tasks and add in the Windows, like I'm sorry, these things have been garbled by latex compiler, it's not able to compile them properly. So this is a task, and then this is a time, and then this is the target which will be executed at that particular time. So this is another way you can get persistence. Then the next one is you have a startup folder in this particular location. So C app data Microsoft Windows startup menu program startup, or C program data Microsoft Windows start menu program startup. And there also, if you write something into this, if you put something into this folder, those programs will automatically start executing. So you can check all this. So if you are, even if your system is getting slowed down, and if you want that, okay, this software I do not want it to be started by default. I want that, okay, if needed, I will start it. Then you can just remove them from the startup folder. They will not execute by default at the startup. Then obfuscation, I have already told. So this is the normal Caesar cipher, you know. Normally the attacker does, so the normal conventional way in malware field is base 64 encoding. People use base 64 encoding. Now what base 64 encoding is, we have 64 characters starting from 0 to 63. And you will see here that A is represented by 0, B is represented by 1, C is represented by 2, and so on. So all capital Z 25, and then small a 26, and so on. Here small z, and then you have 0, 1 to 9 up to 61, then plus 62, and this symbol is 63. Because in a binary file, say we are going to get some numbers like this, so we can replace them. Like if you have, say, if you want to pass on 1, then the ASCII value will be something like this. And then this ASCII value is converted into binary and then encoded. So once you encode, basically you encode it into 64 bits. So you take this 6 bits together and you get an encoding for that. So that encoding is 19, 54, 57, 37. So this 1 is now converted to T251. So basically you are passing 1, but it is being passed as T251. I hope I'm clear. So this is the encoding table. So what you have done, ASCII characters, 7-bit long. So basically 347, and we put a 0 to make it 8 bits. So this is 79. This is for 1. This is for, and then so 110 and then 101, and we converted them. And then we took 6 bit together. So out of this 8, we take 6 bit, then this plus 6 bit, then 6 bit. So this 24 will now be divided into 4 components. So this 3-letter word now will be represented by a 4-letter word. Similarly, while decoding, we have this one. So we have these numbers, then table value this, and then we group them into 8 bits now. So all these 24 will be written, and we'll take in a group of 8. So we'll have 3 characters, or 3 numbers basically, and so 29, 110, 101, and then as the decoded value is 1. So this is one way. If normally the malware authors decode that. And if you have something which cannot be say multiple of 6, because you will be going into group of 6, like here 4. So you will have 8 into 432, but which is not a multiple of 6. So at last we add zeros, and hence the normal characters, the normal encoded value at last we get is double symbol we add, in order to ensure, or in order to just indicate that there are 4 characters which is not multiple of 4, say multiple of 6. And say while decoding we get something like this. Here also a lot of people, in fact a lot of malware developers, they are, say, use their own intelligence and one technique and remove them. What they do is they remove this padding character. So you saw here that if it is not multiple of 6, we use a padding character. So some malware developers remove this padding character. So if you remove this padding character, so and if you want to decode it using base 32, it will say incorrect padding and you will not be able to decode it. So one way is you can check the length. If it is not multiple of 8, you can basically stop it. So these are these. So then you have cells. If you just add this, you will get that this is a basically a system program which says that this is uh, going to privilege level of user and parent process to command and control center. Then, as I told, the memory forensic technique. So, memory forensic technique, there are two steps. One is memory acquisition. So, we dump the memory, we take a snapshot image of the memory and keep it on the disk. Once it is on the disk, we can analyze it. So there are several softwares for this. Some of them are free, like FTK Manager by Access Data, it is free and quite widely used software. Then there is Cameo, which is again a very good software. Memory analyzed by FireEye, then Surge, and then West Forensics. So these are commercial, but these two are free softwares, FTK Imager and free download with registration. So sorry, Cameo memory. So you can download this and then you can analyze. So if you analyze, you will get a memory tree, the whole structure of processes running into that system, and then based on that you can analyze that how good or bad means whether this has got a parent orphan process doing something, some nonsenses and so on. You can analyze that. Okay, so with that I will stop here. Thank you to all, and if you have any query or anything you need to discuss, it will be a time for that, so we can spend some time for that. Although I have taken the whole time up to 12:30, but still we can discuss some of the questions if you are having.
So thank you so much for providing a valuable insights on this topic. I'm sure each and every one of us has learned a lot from it. So with that, sir, we'll go ahead and take some time for some questions. We've got actually a lot of questions, sir, but we filtered some of them.
Hmm.
So the first question is, sir, is there a way that I can delete spyware manually? It is a question from one of our participants named
Can
Prof.
you repeat the question?
Is there a way that I can delete spyware manually?
Spyware, yes, whatever I was talking was for that only. That if you can identify that if it is a spyware or any malware, you can always delete it.
Yes, sir.
You just shift delete, so it will be deleted from your hard disk permanently. It is ultimately, so whatever we discuss, except this memory forensic, no, they are there on your disk. So if you can find out the location of those files on your disk, this is a normal regular program or regular file you can delete from disk or anything, whatever you can do on the disk. Okay.
Oh, yes, sir. Sir, the next question
So
is,
the next question is
yes, you,
by Nabajit. Is malware analysis a good field to pursue?
Yes, obviously to me, say malwares are going to stay for every time events. Wherever there is a computer, there will be a chance of malware. Do not agree with me? All of you will agree with me.
yes,
Yes?
sir.
So they will be there. And nowadays, these malwares, why this malware analysis becoming so important. Till now, everyone was thinking that malware can only disturb the computer operation. But now malwares can kill human beings also. You'll be surprised to know. So, although fixes yes, you see a movie called as CBI 5. There is a South movie by Mammootty. You see that movie, you will see that this is a hypothetical scenario, but that's not far from reality. Why I'm giving this example? So, a person's say is basically having a pacemaker which is having certain software code. So if there is a software code in a pacemaker, anyone can just put a code into that, basically a malicious code into that, hack that, and then they can control it. They can basically reduce the speed, so basically they slow down the pacemaker. This, isn't it? This is what
Yes,
was shown into that movie, and that is not far from reality. This is true. Now pacemakers are coming which are having software components. Your watches, which is there in your hand, are having software components. So how many steps you are going, what is your say blood pressure, what is your oxygen level, what is your heart rate, everything they are measuring. They can be hacked. Will you
Yes, sir.
agree with me?
Definitely, sir. Yes, sir.
So they can be used to say means do a lot of tricks, a lot of damage to you.
Yes, sir.
So malwares are not only means although this topic was or the discussion was restricted to Windows or Linux, but the same thing, the same idea applies to any IoT devices, any Android devices, any operating system. Okay,
Okay,
so
sir.
they are going to last, and if someone wants to do research, I think this is going to be a very good field. Still, it is a good field, and in future also this will always be a good field. This is never going to end because always the malware developers will give you certain newer challenges.
Yes, sir. Definitely, sir.
Okay.
Okay, sir. Sir, we have another question. It's from Nabajit again.
Hmm.
Sir, is bloatware also considered malware because OS these days come pre-installed with bloatware, sir?
Yes, some people say these are means discussion on that key whether it is a malware or not. It depends on the application or basically the user. So to some extent, since we do not know, they can and they steal information, no doubt. But since we are means if we are taking a cheaper version of some hardware, and if something is already embedded, we do not know exactly how much damage it is going to us. So obviously, to me, that's a malware.
Okay, okay.
Others may differ.
Okay, sir.
Okay, sir, the next question is from Prashant Chakrabarti.
Mhm.
How does cloud keeps malwares? Is it possible that those malwares can affect the containers or dockers where it is stored?
So in cloud system, so basically in the cloud, we are only storing our files, and normally the storage is on a faith that the cloud provider is having a good malware services. No doubt bigger organizations are managing that, so they have a better antivirus systems in practice. They are scanning everything, but still, having told so, still there is a chance that people can enter into that system. They can disturb the file, they can, and they are in fact having more chances of being attacked, because say hardly someone is going to attack a student system because they know what they will get. Ultimately they will get some movies, they will get some music files and some assignment files, that's all. But where the attacker will target, they will target to some organization, because if they can encrypt an organization's say HR manager's file or say design manager's computer and ask for ransom, they had to. So bigger organizations are at more risk. So in that sense, you can say that okay, uh, we cannot do anything in terms of the virus protection. The organization is responsible, but obviously it is having more chances of attacks also. To me, again.
Okay, thank you, sir. Sir, we have another question from Neelam as Bora, one of our participants. How is payload generated so that it has the ability to infect multiple architectures?
Okay, so since this course was not about, or this talk was not about malware development, so we
Yes.
have a complete course on that, ki how to develop a malware. So it needs to take care of architecture and ultimately say it's a for loop. You think of simply. So if you are a computer engineer, you have a for loop. So basically, whenever you are create many versions, that means you have a for loop and you will be targeting to each and every environment or direction. So same program with certain slight changes, you are adapting to several systems or worms. So basically a for loop which keeps on generating something. So the idea is very simple, but obviously this payloads, the development of payload itself is, it requires an expertise or basically some time. So normally I prefer or I do not offer those courses of payload generation or malware development. I mostly believe in the malware analysis of stopping that.
Okay, sir.
Okay.
Yes, sir.
Okay, sir, we have another question from Deep Haloy.
Mhm.
Can cookies be used to insert malware in a computer or steal data from computer?
Cookies again. Say, if I can inject some sort of codes there in the form of cookies, obviously yes. If I say cookies is very simple information I'm keeping, but if I can build on say regularly if when someone is hitting a website and if I keep on building some sort of small cookies and finally they can be assembled into a simple program on my system, they can be tracked to attack. Say you can imagine any way attackers are using. There is no way you can say that this way it cannot be attacked. Every possibility is there.
Yes, sir. Sir, would you like to take another question or?
Yes, if there is any question, we can discuss.
Okay, sir. There's another question. Sir, is Linux more safe from viruses than any other Windows devices?
Say, Linux is no doubt safer than Windows platform. First thing is key Linux has user separability, and then no, mostly the economic point of view also plays a stronger role. Windows platforms are mostly used by users which are novice. Means, say, if you are thinking of, say, just stealing money is your target, then to whom you will target? You will target the common people, those who are not very expert, and most of them are using Windows platform because Windows is more user friendly, or Android platform nowadays.
Hmm.
On the other hand, Linux is mostly still considered to be used in research organizations where people are only using research or even the servers. So big organizations are also being hacked nowadays. So they are mostly running with Linux also. But common viruses, what we saw, are mostly developed for Windows platform.
Okay, sir. Thank you, sir. That will be it, sir.
Okay, then thank you. Thank you for your interest
Thank you,
and so
sir.
many
Thank you,
questions.
sir.
I hope that this talk will really be meaningful to you. And thank you.
Absolutely, sir. Absolutely, sir.
Thank you so
Thank
much,
you, sir.
sir. We hope to keep this sincere and fruitful bond even in the upcoming days. Thank you so much.
Okay, thank you. Bye.
Thank you, sir.
And
Okay.
registered participants, we have provided a Google Form link in the comment section. You will have to fill up the form to get the certificate. And those questions which were not answered, we'll try to answer them personally or by WhatsApp or by email.
Okay. Thank you. Thank you, everyone. Please do fill up the
And
Google
let's
form.
join in the next session at 2:30 p.m.
Yes. Thank you.
afternoon, sir.
Good afternoon.
Okay, sir. So we'll be starting off with the last session of our workshop in a few minutes. The
So
workshop will be
all
streamed.
participants joined?
So they will be seeing it via YouTube. We
Okay,
have streamed the video in YouTube as an unlisted video.
Okay,
And only the registered viewers will have access to the video.
okay.
Good afternoon, sir. Good afternoon, sir.
Good afternoon. Good afternoon.
Okay, the stream is live now. Devanga and Plavita, you can start.
Okay. Okay. Plavita, will you start?
Yes, I'm starting. Good afternoon, everyone. As you all know, the workshop is being streamed in YouTube as an unlisted video. Only the registered viewers will have access to the video streaming. The viewers will be able to put up their questions in the live chat box, and we will be putting forward the questions one by one. And the organizers will be watching it via Google Meet. So if you have any questions, please feel free to type them in the live chat box, and we'll take up the questions towards the end of the session. Also, we will have a feedback form at the end of the session wherein you'll have to answer the questions. Certificates will be provided to the participants after completion of the event. Please keep in mind that only those who are able to answer the questions given in the feedback form correctly after each session will get the certificate.
Thank you. So after successfully completing 3 sessions of our 2-day workshop, we'll be starting off with the last session now. For the last session, we have with us Dr. Satyajit Sarma, sir, Assistant Professor, Director of Department of Information Technology, Guwahati University. He has around 10 publications and some great research work. He will be taking the workshop on cryptography. So without any further delay, I would like to request Satyajit Sarma, sir, to continue with the workshop. Thank you, sir.
Okay. Thank you, Devanga and Plavita, and other organizer, basically from 5th semester, na?
Yes, sir.
Okay, I am sharing my. So is it visible?
Yes, sir.
Yes, sir, it is visible.
Okay.
Sir,
So basically,
excuse me, sir.
I will speak on network security challenges and opportunity. So in this network security topic, I will cover all the cryptographic technique and also some algorithm for prevent different cryptographic attack. So these are the contents I will be covering in my lecture. What is security? Then security goals, common security attacks and their countermeasures. Then what are the challenges that we face? Then what are the opportunities for us? And finally, what are the different applications of machine learning technique in network security or cryptography? And the conclusion. So these are the outline I will be covering in my lecture. So first, we'll discuss what is security. Basically, if we want to define security, first we'll tell freedom from risk or danger. So that is called safety. So security is one kind of safety. We should be free from risk or any other danger. Then something that gives or assures safety. So that is also called security. If someone gives us safety or assures safety, then we may call it security. Then freedom from doubt, anxiety, or fear. So if we are free from doubt, anxiety, or fear, then we may call it security. Then also, in case of our computer system or information system, the protect vital information while allowing access to those who need it. If we can protect, then it is called security. And sometimes if you provide authentication and access control to some resources, so that is also we can speak as security. So finally, we can tell guarantee availability of resources. So while incorporating security, we should also consider that all the resources should be available. It should be guaranteed. Then, so we are talking about security, we are talking about cryptography, we are talking about system security, network security. Basically, why we should study or we should learn cryptography or network security. So what are the basic goals? So basically, we have the 5 or 6 basic goals. So basically, we have 5 basic goals and another is additional goals. So first, we'll tell what is confidentiality. So confidentiality means, so confidentiality should ensure that no any third party or no any person can get the actual or private content of your message or information. So if someone get your private information or confidential information, so your confidentiality will be lost. So that is why our prime goal of our security is to we should ensure the confidentiality of any other confidentiality of any kind of confidential data or important data. Then second security goal is basically authentication. So what is authentication? That means authentication ensures that only authenticated users will be able to access the resources. So our intention, our goal is to ensure authenticity so that only the authenticated users can able to view, access or access or modify the actual content of the message or any other stored information or data. Then third goal is integrity. So, or we can say it's a data integrity. That means integrity ensures that no any person or no any unauthorized person or attacker can modify actual content or data of the messages. So whenever we are incorporating integrity, we should ensure that no any person or no any third party can modify the actual content of a message. If someone can modify the actual content of a message in between communication during transition, during transit, then we will call it data integrity or integrity lost. So our one important goal of cryptography is to achieve integrity. Then fourth point is non-repudiation. So this is one of the important goal of our cryptography or network security. So actually what is non-repudiation? So non-repudiation ensures that after doing some transaction or after doing some event, no any person or no any entity can deny or refuse. So one example is someone has transferred some amount from his account to another account. After some time or after some days, he or she can refuse that I have not done the transaction. So basically, that type of situation may happen. So non-repudiation ensures that no any person or no any entity can refuse or deny his previous commitment. So basically, digital signature is one good example of achieving non-repudiation. So whatever you do digitally, you have to sign digitally. Then it will be ensured that you have, since you have digitally signed in the document, after some days or after some times or after some hours, you cannot deny or you cannot refuse. So basically, non-repudiation ensures that no any party or no any entity can refuse his or her previous commitment. Then next point is access control. Access control is one mechanism through which we can prevent define access control mechanism. So there are various ways through which we can provide access control. One is providing user ID or password. Will then also in case of our system, we can have different categories of users. Then we can define which user will be able to which section. So in this way, there are some different mechanism through which we can provide different access control mechanism to a system, to a server, to a resources, to a information data repository, like that. So basically the first fifth, confidentiality, authentication, integrity, non-repudiation, and access control, these are the main security goals. But while incorporating or while integrating or while including those security measures in our system or in our resources, we should consider a last parameter also, availability. So availability ensures that all the system, all the site, all the server, all the resources should be available to the valid users 24 into 7. That means while incorporating confidentiality, we should not do that so that so that a authorized person cannot view or get the actual content of the message. Or sometimes what happens while integrating different access control mechanism, sometimes what happens, authorized users also cannot access the resources, but that should not be happen. So while integrating confidentiality, authentication, integrity, and non-repudiation and access control mechanism, we should consider the availability also. That means all the system, all the resources should be available to the valid users all the time, whenever they want. So basically, these are the security goals, and whole cryptography or network security algorithms or method or techniques are basically trying to achieve all these security goals. So basically, whenever we talk about security, who is vulnerable? So basically, who become the victimized? So nowadays, financial institutions and banks, financial organizations and banks are becoming the main target for the attacker. So most of the time, attacker tries to defeat the security measures of financial institutions and bank, and they try to loot money. They try to steal money. So the financial institutions and banks are the prime target of the attacker. So this is one major point of vulnerability. Then second one is medical companies and pharmaceutical companies. So basically nowadays we have lots of pharmaceutical and medical companies, and all these companies have lots of private data, important data. But so that is why many many unauthorized person are trying to get the important or very important information of medical companies. They are trying to day and night, they are trying to steal the important information from the companies. They are manufacturing, they are production information, so like that. So nowadays, they are also becoming the prime target of the attacker. Then third one is government and these defense agencies, basically defense agencies. So say in our country we have a defense agencies or defense mechanism. So some country like Pakistan, they are trying to get our important defense information by different using different approaches, with different practices, by different method. They are day and night. They are trying to get the actual or our private information from the defense mechanism. So that is why, and government also have lots of confidential and important data. So this third party or unauthorized party or attacker is trying to get the government and defense agencies' private data day and night. Then multinational corporates and companies also have lots of important their private data. So the attacker also trying to get this confidential or important data of multinational companies. So that is why multinational companies are also becoming the prime target of the attacker. Then websites and web information. So nowadays, every organization, every education institute, every government agencies and any other agencies, they are keeping their important information in the website. So that is why websites are also becoming a prime target of the attacker. So most of the times what happens, sometimes during some important event, sometimes some website goes down, or sometimes if some attacker get access to the website, they modify the vital information of the information website, or sometimes they steal the important information of the website, or sometimes they create some fake website and they give access to the people, and sometimes many people become victim of that website phishing. So that is why website or web information also becoming a major or prime target for the attacker. Then university colleges organize a confidential data. Basically in university, uh, we have students result. This is a very confidential data. And also in case of finance section, there are lots of confidential data in the finance section. So many attacker or many unauthorized persons are day and night, they are trying to get the confidential information. They are trying to modify the examination system. They are trying to modify the result of the system. So that is why this university and colleges confidential data has become a major target for the attacker. And next one is social media users. So nowadays, social media users are also becoming vulnerable sometimes. So nowadays, there are lots of social media attacks are going on. We have seen many of us have faced this problem. So sometimes in probably in for Facebook, they create a same Facebook account of person, some person, and they send some request to the users, and they ask money, they ask help. So that type of problem is going on. And in case of WhatsApp also nowadays, they create a replica of the WhatsApp account, and they send some messages to the friend or relative, or they try to get money, or they try to get some confidential information through social media. So that is why social media users are also becoming nowadays a major point of vulnerability. Then finally, we can say anyone on the network. Since nowadays we are dependent on the network from morning to night, we are dependent on the network. We do everything online: class, online transaction, online banking, online ticket booking. So every transaction is done online. So that is why, since we are dependent on the network, we at any moment we can become vulnerable. So that is why I have termed as anyone on the network can be vulnerable. So there are some common security attacks and their countermeasures. So basically, what are the common security attacks? So basically, finding how security attacks are happening. So finding a way into the network. So whenever you are in a network, the attacker, the third party, is trying to find a way into the network. They are trying how they can be entered to the network, and if somehow they enter to the network, they try to do some unwanted activities, and through which they can harm all the users or all the system connected to the network. Then one another way is exploiting software bugs or buffer overflows. So whenever we are designing some system or application, there may be some software bugs. An attacker tries to find the software bugs, and if they can try find the software bugs through the software bug, they will enter into the system, or they will enter into the application, or they will try to do some unwanted activities. Then denial of service. This is one attack which is popularly called DOS attack. So basically, DOS attack, a main goal of DOS attack is to disrupt the availability. So basically, the DOS attack is multiple users will try to will send some request to the server or to the system, and as a result, that particular server or the system will not be able to give us the service, and that particular attack is called denial of service attack. So nowadays we have DDoS attack, distributed denial of service attack also. So in case of distributed denial of service attack, that particular attack is done from distributed environment from different location. So that is why this is called distributed denial of service. Then another popular attack is phishing attack. So phishing attack is basically nowadays very common. People try to people will modify the interface and will send some request to through some kind of communication media like mobile phone or like Gmail or like Facebook or any other messenger, and they will try to convince the people that this is a valid system or valid application, and in this way people will try to enter into the system providing his actual information, actual credential, and in this way they may be victimized of the phishing attack. So phishing attack is nowadays very common. Then another attack is called packet sniffing. So all of we know basically so during communication, basically in network data is transferred in terms of packet. So there are some tool, there are some application, there are some system through which we can sniff the packet or we can capture the packet, and by capturing or sniffing the packet, we can get the if we can get the important information by using packet sniffing method. So we'll go into detail about packet sniffing. So then next attack is injection. So basically SQL injection is a very popular attack. So in whenever we design some system using some SQL database, then we may face SQL injection attack. So in SQL injection attack, what happens? So basically attacker will try to find the loophole of the SQL, and they will try to include or incorporate some SQL injection, and by using SQL injection they will try to find out the have important information from that database. But nowadays we have some mechanism while writing the SQL command or coding to prevent SQL injection attack. So next, another common security attack is malware. So malware is also important. So nowadays, what happens whenever we download some software or whenever we download some application in our mobile phone or in our laptop or desktop, so unknowingly some another applications or some system may be installed in your PC or in your laptop or in your mobile. So that may be malware. So this malware is also becoming a very common security attacks nowadays. So that is why we should be very careful while installing some software or system in our mobile phone or in our laptop or in our desktop PC. So then another common attack is botnet attack. So basically botnet is, so it's a network of some bot, and basically this bot will create some network and they will try to attack into the system. Then another common attack is insider threat. This is very dangerous because insider threat is very difficult to detect. So if some attacker is inside our system or inside our environment or inside our resources, it is very difficult to identify whether it is a attacker or it is a normal user or normal system, normal application. So that is why insider threat is also a very dangerous attack, and that is why we should be very careful in insider threat. Then social engineering attack. So already we discussed in case of social media, we have lots of attacks are there. Already we discussed through Facebook, through WhatsApp, or any other communication media or social media. We may face lots of attacks. So that belongs to social engineering attack. So now we'll discuss some of the countermeasures through which we can prevent those attacks or some preventive mechanism. So the basic countermeasures is encryption. So whenever we'll send some data to the send data from sender to the receiver, so the basic way is encryption. That means we'll hide the actual meaning of the content of the message, and we'll transfer the data in encrypted format. So This particular mechanism is called encryption. So encrypted data will be sent, and if we send some encrypted data, then there will be no chance of any man-in-middle attack or any other attack. And if someone steals the message during communication, then also he or she will not be able to get the actual content of the message. Then another countermeasures is use of different cryptographic algorithm. So now we have lots of cryptographic algorithm from stream cipher to block cipher, then public key cryptography to symmetric key cryptography, or and lots of cryptographic algorithm like hash function, MD5. So we can use different cryptographic algorithm depending on the situation and depending on the application. So this cryptographic algorithm is a good countermeasures for the security. Then use of additional security protocol. So we can use or additional security protocol. Nowadays, SSL is very important. So many organization or many website they uses SSL certificate. So basically, SSL is nothing but security socket layer, secure socket layer, and the position of SSL is on between application layer, top of the transport layer, in between application layer and transport layer. So additional layer, SSL layer is introduced, and basically SSL layer job is to secure the communication so that the message does not transmit as a plain text message. And in network layer also that IPsec protocol is used. Basically IPsec resides on the top of the network layer, and basically IPsec has two parts. One is ESP, encapsulation security payload, and another part is AH, authentication header. So basically ESP, IPsec provides confidentiality and authentication. So basically SSL is on the top of transport layer and IPsec is on the top of network layer. So SSL is used by the transport layer and IPsec is used by the network layer. Then we have different verification mechanism also, OTP. So some nowadays we have, though we have user ID and password, for accessing some system or the resources, we need to provide the one-time password that is sent to your mail or mobile number. Then also we have different access policy that we can use as a countermeasures for prevent different security attacks. Then another countermeasures is firewall. So basically what the firewall is the only one point of access into the network. So at the entry and exit point firewall is located. It can be a hardware or it can be some software. So nowadays some routers come with firewall functionality. As nowadays if we install some routers, that routers come with firewall functionality, and we can also, our network administrator also can install or configure some firewall. So in that firewall we can use some packet filtering mechanism. That packet filtering mechanism may be a rule based. So we'll install or you will incorporate some rule on the firewall, and at the entry and exit point of the exit point, that is the firewall, and depending on the rule that we have configured or that we have designed, the firewall will work. So there's an example. So if we configure a rule like that, drop packets with destination port 23, that means telnet. So basically telnet use port number 23. So if we configure that all the packets with port number 23 will be discarded, then when a traffic will come with port number 23, then all the traffic will be discarded in the firewall. So in this way, in the firewall or router, we can put, or gateway, we can put some rule, and depending on the rule, that particular firewall will work, or that particular router will work. So basically, that particular firewall may be hardware, or most of the times it is nowadays software. So basically, this is the how firewall basically works. Basically, this is the internet, and this is the internet. In between internet, there will be firewall, and there will be some uh, devices. It may be router or proxy server like that. Then another countermeasures is intrusion detection system. So basically, intrusion detection system is used to monitor for suspicious activity on a network. So we can have a intrusion detection system. So basically that intrusion detection system will continuously monitor the suspicious activity. And if some suspicious activity is reported, immediately that particular intrusion detection system will report to the network administrator or the owner, or it can protect against non-software exploit like buffer overflows. So intrusion detection system can protect against the software exploits like buffer overflows. So we have some open source intrusion detection system, which is one good example is Snort, which is available at www.snort.org. So you can check using that website. Then intrusion detection system uses intrusion signatures. So basically, what is intrusion signatures? So it's a well-known patterns of behavior. So ultimately, the behavior pattern is identified, and based on this behavior pattern, intrusion detection system will take some decision. So another good example is port scanning. So sometimes we may have port scanning facility or port scanning system. Sometimes we may have DOS attempts. So we can, using intrusion detection system, we can identify or we can find out whether any DOS attempt has been occurred in the system or not. Then we have some attack like to prevent dictionary attack. So there's a popular attack which is called dictionary attack. So to prevent dictionary attack, we can have the password will be stored in an encrypted format using some cryptographic function. So we have lots of cryptographic function or cryptographic algorithm, and to prevent dictionary attack, we will store the password in an encrypted form. Then also we can use of one-way function on the password. Basically, we will perform on the one of the way function of the password. So what is the significance of one-way function is, in case of one-way function, it's a nothing but it's a mathematical function or any other function. But the beauty of this function is it's a one way. That means if we have the plain text from the plain text, we can get back the cipher text. But from the cipher text, we cannot get back the plain text. So that is why it's called one-way hash function. So, or sometimes what happens, on the plain text, we will perform some mathematical operation or hash function, and result of the hash function is some digest. And beauty of this algorithm is, from the plain text or the message, we can generate a digest using one-way function. But from the digest, we cannot get back the plain text. And this is the beauty, or this is the security of a one-way hash functions. So if we perform some one-way hash function, then we will on the password we will perform some one-way hash function, and in the database we will store the digest of the password. So that is why in many of the system we cannot get the actual password, but we can reset the password. So the reason is, on the password, one-way function is performed, and instead of storing the password, the hash value or digest is stored in the database. So that is the strength, or that is the beauty of the one-way hash function. And to avoid key distribution and exchange problem, so in cryptography, what happens, if the users are in different location or in different places, major problem is how the key will be shared. So normally what happens, whenever you apply for a ATM card in your SBI, so earlier what SBI did, as earlier SBI shared the password in an envelope. So ultimately whoever get the envelope, he or she could try to access the ATM card. So that means sharing the key is a major problem. But nowadays, whenever they are sharing the ATM pin SBI, they ask us to activate using ATM card. So using our mobile number. So another feature is additionally added. So to avoid key, so same situation occurs when two communicating parties are in different location. Then how the key will be distributed or key will be exchanged. So to avoid the key distribution or key exchange problem, one algorithm was proposed. This is a very common algorithm, RSA. So this was developed by Reves, Shannon, and Edelman, three cryptanalysts. So they developed RSA algorithm. And in case of RSA algorithm, there is no need of key exchange or key sharing. So encryption key and decryption key is different. And also there is another algorithm which is called Diffie-Hellman key exchange algorithm. In case of Diffie-Hellman key exchange algorithm, what happens? Instead of sharing the key, they share some particular number, and key is computed at the sender side as well as the receiver side. And the main beauty of this algorithm is, though it is generated in different side, sender side as well as receiver side, but same key is generated. So in this Diffie-Hellman key exchange algorithm, instead of sharing the key, they share some prime number. And if someone gets the prime number during communication, they cannot find out the key. So this is one beauty of the Diffie-Hellman key exchange algorithm. So instead of sharing the key or instead of exchanging the key, they will exchange or they will share some prime number, and both the parties, sender and the receiver, will compute the key their own side. But though it is computed in different side, but same key is generated, and using that particular key, they perform all the encryption and decryption in all the futures communication. Then to prevent brute force attack. So basically, brute force attack is very common. This is a one kind of trial and error attack, guessing attack. So people will try different times and try to defeat the security mechanism. So to prevent brute force attack, some countermeasures is password length should be minimum of 8 characters. Then again, password should contain uppercase, lowercase, alphanumeric characters like that. And the main reason of putting this is which leads to more time consumption. So if you provide that type of permutation combination, which will lead to more time consumption. So this is the mechanism for preventing brute force attack. Then already we discussed what is denial of service attack. So basically the main purpose of denial of service attack is make a network service unusable, usually by overloading the server or the network. So main intention is how we can make the system or the server unusable for the valid users. So that can be done by overloading the server or the network. So many way or many approaches for performing DDoS attacks are SYN flooding. So basically SYN is used for synchronization during connection establishment. So using SYN flooding attack, we can perform DOS attack. So we can artificially or using some app or using some tool, we can perform SYN flooding attack, and as a result, we can perform DOS attack. So there are some tool which is called SMARF. So this SMARF, using that SMARF tool also we can perform DOS attack or DDoS attack. And another good example of performing DOS attack is ping of death. So basically ping request is sent to check whether a particular network is reachable or not. So using ping of death in this way, we can perform DOS attack. Then distributed DOS. Already we discussed the main difference between DOS and distributed DOS is DDoS is, in case of DOS, the attack can be from a single point, but in case of distributed or DOS attack, the DDoS attack may be from different environment, from different distributed environment, from distribution node or multiple node. So for preventing DOS attack, we have a mechanism called ingress filtering. So in case of ingress filtering, we can also have some rule or some configuration. So good example is if the source IP of a packet comes on an interface which does not have a route to that packet, then drop it. So we can perform some filtering mechanism based on the packet. So
Excuse me, sir. Sir,
Yes.
will you click the hide icon at the bottom, sir? Actually, it's blocking the view of the PPT. Stop sharing and hide icon. That.
Is
Okay,
okay?
thank you, sir. Thank you, sir.
And I am going so fast?
No, sir, the pace is okay.
Okay. Then ingress filtering is one way for preventing denial of service attack. Then another one is content filtering. So basically, in content filtering, what happens using some tool or using some method will capture the packet or will check the content, and based on the content we can allow the users or you can restrict the users. So this is one mechanism through which we can prevent denial of service attack. Then another mechanism is using virtual private network using VPN. So basically, bank uses virtual private network. Then we can have load balancing method. Load balancing method is basically some load will be balanced on the server. So before the server goes down, the load will be balanced, and there will be some kind of threshold value. And when the threshold value will be exceed, the load will be distributed or load will be balanced. So load balancing is a good way through which we can get rid of from denial of service attack. Then firewall is also one mechanism through which we can get rid of denial of service attack by integrating some rule at the firewall. Then nowadays there are some machine learning or AI approach for preventing denial of service attack. So people are using machine learning technique for analyzing the data or some artificial intelligence approaches for preventing and detecting denial of service attack. Then another problem is social problems. There are not always solution to all these problems. So humans should be careful into giving out information they should not. So nowadays what happens? So this cyber attack is becoming a social problem. So attacker or unauthorized person are using different way. Sometimes they may call you over phone and they will try to cheat you, providing you different information or asking your vulnerable information like your ATM pin. Sometimes they will try to convince you that your ATM going to be expired. So that is why humans should be careful into giving out information they should not. That means we should not share our vulnerable information or our important information, even our own information, if we don't know the party well. And educating them may help a little here. So now that means we should create some awareness, or we can educate the people so that they cannot provide their vulnerable information to the unauthorized or unknowing person. Then creating cyber awareness is one of the common countermeasures. So we should create some cyber awareness among the people. Then we should not share our information to untrusted party, and also avoid transaction from our public access point. So nowadays, what we do, wherever we go, immediately we connect to a public access point. But actually, we should avoid that particular habit. Now, so many people has been become victimized of using public access point. So if there is no any proper security mechanism, and if there is no any authentication mechanism, we should avoid transaction. Basically, we should not do bank transaction. We should not re-log in, or we should not provide our vital information using in the system using public access point. So in the last half an hour, we have discussed lots of cryptographic technique, as well as how different cryptographic attack or network attack and some their countermeasures. But we have lots of challenges. So what are the challenges? Though we have lots of method for prevent or different security threats, still many of the resources, data, transaction are compromised or vulnerable. So already we talk about many algorithm like RSA, we have talked about the Feldman key exchange algorithm, we have talked about block ciphering technique, we have talked about other algorithm like DES, one-way hash function. Still, our system, still our resources are not 100% secure. Still, it is our transactions are compromised or vulnerable. So basically, one of the main challenges is to detect these unwanted or unauthorized activities. How we can detect these unwanted or unauthorized activities and before happened. So many times what happened, so we can detect the unwanted activities when some amount of money has been stolen from our account. But our challenge is to we should be able to detect these unwanted or unauthorized activities before it happened. This is a major challenge. So another challenge is to how to prevent these unauthorized activities, how we can prevent. One challenge is how we can detect this activity, and another challenge is to how to prevent these unauthorized activities. So nowadays, we are using some modern network like IoT, we are using SDN software defined network, we are using cloud for different activities like our home automation, our medical, in our agriculture, in our industry management, in our smart city, in our data monitoring system or many real-time application we are using this modern network. Like most of the times we are using IoT. And greatest challenge is to how to secure these IoT devices or software-driven modules from unauthorized accesses. So this is the greatest challenges nowadays since we are using IoT devices everywhere. IoT network in agriculture, in our medical, in our home automation, in our smart city. So this is the great challenge for us how to secure these IoT devices from the unauthorized access from the attacker. So now we'll highlight some of the traditional methods for security. So traditional systems or methods were based on the rule or known signatures to classify the malicious content. So basically traditional methods or system is rule based. We'll define some rule or based on some rule or known patterns or signature, we will classify whether it is a normal or whether it is abnormal. But nowadays, attackers are more smarter and sophisticated. Nowadays, hackers or attackers are more smarter and sophisticated, and they are capable of bypassing. They are capable of bypassing all the traditional rule-based system what we designed, whatever system we have developed or what we are using. They are capable of bypassing all these mechanisms, and at this point, traditional systems sometimes get invalid. So, so all the traditional systems sometimes get invalid. And here the importance of machine learning and AI comes to the scenario. So that is why sometimes nowadays machine learning and artificial intelligence has come in the scenario of network security. So machine learning and artificial intelligence systems are based on behavior rather than rules. So earlier what we do in the cryptographic algorithm using firewall or any other rule-based approach, we design some rule, but since the attacker or attackers are more sophisticated or more smarter, they they some they can defeat our security system. So that is why we are using machine learning technique or artificial intelligence. And basically artificial intelligence and machine learning works on behavior rather than the rules. And machine learning and AI models get better in analyzing the behavior and recognize patterns with more data. So if the data is available, or if we have the data, or if we have the behavior, then machine learning and AI model can analyze the behavior or the data or the pattern better way. So thus implementation of machine learning and AI in the field of security is one of the most essential tasks for now and upcoming time. So that is why using machine learning approach or ML approach or AI approach, you can have better analyzing, you can have better analysis in the field of network security in the near future. So now, what is basically machine learning? So machine learning is a branch of artificial intelligence and computer science which focuses on the data and algorithms that way the human learns or gradually improving its accuracy. So basically machine learning is all about data and training the machine to a specific pattern depending upon the behavior of the data. So we have different types of machine learning. One is supervised another is unsupervised, and third one is reinforcement learning. So basically, in case of supervised learning, the training data set is pre-classified or output is already specified. But in case of unsupervised learning, the data set is not classified or output is not specified. In case of supervised learning, based on the data, the model is basically trained. But in case of unsupervised learning, the algorithm searches for some pattern or structure in the data, and based on this pattern or based on this structure, they try to cluster or classify the new data. So there is no any predefined classified data or predefined model. But in case of unsupervised, in case of supervised, there may be some pre-classified data or output is already specified, and based on this, the model is trained. But in case of unsupervised learning, the algorithm searches some pattern or structure in the data, and thus they can classify or cluster the data. And in case of reinforcement learning, the machine behaves based on the environment. So basically, based on the environment, input from the environment, it behaves. So if you talk about benefits of ML in security, so ML can automate tasks. A great benefit of machine learning in cyber security is to its capacity to automate repetitive and time-consuming tasks such as triggering intelligence, malware analysis, network log analysis. That means using some automated system, machine learning approach can analyze malware automatically. It can analyze the log of a network automatically, and also it can assess the vulnerability automatically without any human intervention. So that can be done using machine learning. So that we can do automatic task. Then threat detection and classification. So using some machine learning algorithm, we can detect the threat, and also we can classify whether that particular traffic is normal or whether that particular traffic is abnormal or attack. So threat detection and classification is also can be done in using machine learning algorithms. Then the latest machine learning algorithm who uses predictive URL classification. So that predictive URL classification models can identify patterns that reveals the malicious email. So this predictive URL classification model, which is based on machine learning, can identify the patterns which reveals the malicious email. So malicious email can be identified using predictive mechanism using machine learning. So to this, the model are trained on features such as email header. So based on the email header or body of the data, they can predict whether this is a malicious or whether this is a harmless. So based on the email header or based on the pattern or based on the data of the body, that URL predictive URL classification model can decide whether this is a malicious traffic or this is a harmless traffic. Then web shell is a good example. So basically, what is web shell? Web shell is a piece of code that is maliciously loaded into a website to provide access to make modification on the web root directory on the server. And this allows attackers to gain access of the database. So using web shell, attacker can gain access to the database, but using machine learning approach, state of the behavior can be detected and the model can be trained to differentiate between normal and the malicious behavior. So using this machine learning approach, that web shell can be detected as well as prevented. So web shell is nothing but it's a piece of code that is maliciously loaded to gain the access to the database. And using machine learning model, we can prevent as well as detect this web shell. Another is network risk scoring. So machine learning can be used to analyze previous cyber attacks dataset. So basically using machine learning, we can analyze the previous cyber attacks datasets based using defined approaches. We'll analyze the previous dataset, and based on that analyze, that particular method will be able to determine which area of the network is mostly vulnerable and which area of the network is secure. So that is called network risk scoring. This score can help quantify the likelihood and impact of an attack with respect to a given network area. That means, so if the particular network area is harmful, then the network risk scoring will be high. And if the network risk scoring is very low, that particular network area will be somehow little bit secure. So thus helping organization to reduce the risk of being victimized by further attacks. So network risk scoring is one of the approaches which can use machine learning approach for prevent different network risk. Then we can, what are the different applications of AI and ML in network security? So basically we can find threats on a network. So machine learning can detect threats by constantly monitoring the behavior networks. So machine learning can constantly monitor the behavior of a network, and if it detects some anomaly, immediately it will be report. Then keep people safe when browsing. So machine learning can predict bad neighborhoods online to help prevent people from connecting malicious website. It can help people so that people do not log into a malicious website or do not enter to a malicious website. So machine learning analyzes internet activity automatically to identify the attack. Then protect data in the cloud. So nowadays people store data in the cloud. So machine learning can protect productivity by analyzing suspicious cloud app login activity based on the location-based anomalies and conducting IP reputation analysis to identify threats and risks in cloud apps and platforms. So basically, whenever we store data in the cloud, in that cloud also we can have some machine learning technique through which we can monitor and we can find out or we can analyze suspicious activity that are going on in the cloud. And if any suspicious activity is going on the cloud, immediately it can be reported. Then detecting malware in the encrypted traffic. So nowadays most of the times most of the traffic is encrypted from. Machine learning also can detect malware in encrypted traffic by analyzing the encrypted traffic data elements in common network telemetry. Rather than decrypting, machine learning algorithm pinpoints malicious pattern to find threats hidden with encryption. So sometimes with the encrypted data, some malicious pattern or malicious data can be included. So machine learning technique can also can nowadays detect the malicious pattern that is hidden inside the encrypted message. So in this method also we can use for find out the or detecting the malware in encrypted traffic, we can use machine learning. So basically whenever we talk about machine learning, how basically machine learning works. So basically to work with machine learning in network security, we should have a data set. So that is the data collection phase. So once the data collection is done, so data collection is a major step, how data will be collected. So once the data collection is done, second phase is data pre-processing, how data will be pre-processed. So once the data is pre-processed, then next is feature extraction. The different features will be extracted from the dataset. Then feature selection. So some features will be selected using some process. Then once the feature is selected, then model will be trained. And once the model is trained, finally it will be evaluated and performance analysis will be done. So basically this is the workflow model for creating a machine learning model. So the phases are, one is data collection. So basically data collection is one of the most important as well as difficult part in the machine learning domain and especially in the network security domain. So in case of network security domain, basically a real life network is to be set up. Main job is to we have to set up a real life network. And once the real life network is set up, then we have to launch some attack, we have to perform some real attack. And once the real attack have been performed, then we have to capture the network traffic. So basically, this is a very time-consuming task, data collection. So nowadays, we have some people organize as CTF challenges to simulate a real-life attack scenario. So there are some CTF challenges, try hack me or hack the box platform. So these are some way through which data can be generated. And nowadays we have some standard dataset also. We can download this standard dataset and we can directly work on it. So we need not generate the data. Already some available dataset is available in the web. So we should download the standard dataset and also we can directly work on it. Then we have some tool through which we can collect data from the network. Warsack is a network protocol analyzer or application which can capture the packets from the network. So basically, we can easily capture the packets using that particular tool and store somewhere, and ultimately we can analyze the packet based on the filters using this Warsack toolkit. The output files are basically saved as PCAP file. The packet information can be also exported as a plain text or CSV format or any other JSON or any other format. So basically, Warsack is a very popular tool through which we can capture the traffic. Then TCP dump is one of the another tool through which we can capture network traffic. TCP dump is a CLI-based data network packet analyzer computer program. It allows the user to display TCP IP and another packets being transmitted or received over a network to which the computer is attached. And using TCP dump is a very simple command. In the Linux environment, basically you can try using TCP dump. This is the simple command. 2-3 commands can capture the traffic. And along with the TCP command, we may have different options as desired. So you can try it, TCP dump. So TCP dump then works out. These are the common tool for data collection. Then next page is data processing. So the recorded data are raw, and so there exists lots of artifacts and it decreases the quality of the data. So that is why we have to pre-process the data. So in order to improve the quality of the data, pre-processing of the data is one of the most important phase in machine learning. So we have to pre-process before working on it. The recorded packets contains many information and those informations are to be extracted in a suitable format for clustering. Therefore, PCAP files are converted to CSV file and Warsack can be used for this task. For data pre-processing task, we can use. Then CSV file generated from the PCAP file contains information such as serial number, time frame, source. So basically these are nothing but the packet header information. So whenever we talk about packet capturing, so basically in case of network layer, packet is traveled, data is traveled in terms of packet, and every packet will have a packet header, and packet header will have some lots of data like source IP, time frame, destination, protocol, time to leave, length. So basically these are the parameters that a packet carries, and whenever you capture this packet, that particular data will be stored, data will be captured, and that particular data will be stored in the cap file. Then from pcap file we can convert it to CSV file. Now the data is labeled according to the problem statement, and based on the problem statement and data, the labeling tasks may need to be done after feature extraction or selection as well. And some libraries that help in pre-processing tasks are pandas. These are open library, pandas, numpy, matplotlib, etc. So these are the libraries nowadays available. You can try it. Once the data have been pre-processed, so next phase is feature extraction. So after basic pre-processing of the data, the next step is to extract the features from the pre-processed data. From the pre-processed data, we'll extract the features. And the features may be predefined as well as derived features. Some examples are time frame, length, protocol, request per unit, time frame, mean, median. So basically these are the particular attribute that we have captured using TCP dump or WhatsApp tool. So NumPy, Pandas, Matplotlib are some very useful libraries for implementation of the features and extraction it from the data. Then usually the data is labeled according to the problem definition, if not labeled before. So this is feature extraction. So once the feature extraction is done, next phase is feature selection. So this is one of the most important part to identify or recognize the important and best feature among the all extracted features for the particular task. For this task, the importance of the feature is calculated and based on it, important features are selected. So some important features are selected and some of the techniques to calculate the important features are calculating information gain and correlation efficiency. So these are some techniques through which we can calculate the important features in the feature selection phase. Then last phase is training and testing model. After doing so far, the main task to train the ML model, machine learning, we have to train the machine learning model. And training and model is simply means learning good values for all the weights and bias from the level examples. And in supervised learning, a machine learning builds a model by examining many examples and attempting to find a model that minimizes loss. The main target is to build a model which will attempt to find a model which will minimal loss. And last is the evaluating the model and performance evaluation. After training the model, it will be tested over the remaining test dataset that was splitted before training. The model is now evaluated against this unseen data for the model, and based on it, the testing accuracy is obtained. Testing accuracy is calculated. After doing so, for analyze the performance of the model, sensitivity analysis is evaluated. This is one important parameter. The performance of the model, for analyzing the performance of the model, sensitivity analysis is evaluated. And sensitivity analysis is basically a model which determines how target variables are affected based on changes in other variables known as input variables. So based on the input variable, how target variables are affected, and that is called sensitivity analysis. So some techniques for sensitivity analysis are calculating confusion matrix, F1 score, etc. So these are some technique calculating confusion matrix, F1 score. So these are some technique for calculating sensitivity matrix. So now we are coming to the conclusion part. So basically networks are the backbone of all our communication and transactions. So we have to secure it anyhow. Since nowadays we are dependent on the network for all our day-to-day activities or all our transaction, all our activities. So as a student of computer science and engineering or information technology, we should try to secure it anyhow. And machine learning and artificial intelligence algorithms are affecting for solving network security issues nowadays. It can also solve issues like intrusion detection, malware analysis, spam detection, DDoS detection, and different scanning, etc. So machine learning technique is also effective for identification of both known and unknown threats to computers or networks. And finally, we should say whatever we have, but security awareness is one of the important aspects we should consider. So basically, whenever we talk about network security or cyber security, security awareness is one of the prime factor, one of the major concern that we should build, that we should create, that we should be aware. Thank you.
Thank you, sir.
Thank you, sir.
Sir, now we'll go ahead and take some time for some questions.
Okay.
So the first question is from Prasun Chakrabarti. What are the uses of packets? How can one spam packets? How packets are related to DDoS attacks? How can I monitor packets and maybe prevent most DDoS attacks?
So I will answer one by one. So first I will say packet.
Yes, sir.
So basically, when we talk about OSI reference model, we have 7 layers from application layer, presentation layer, session layer, transport layer, network layer, data link layer to physical layer. So most of the layers has their own name of the data segment. So basically, in case of the physical layer, data is transmitted in terms of raw bit stream, raw bit 0 or 1. In case of data link layer, basically data is transmitted in terms of frame. And in case of network layer, basically data is transmitted in terms of packet. So packet is nothing but is a data segment through which data is routed from source to the destination. So it's a data unit. Packet is a data unit. So next question.
Okay, how can one spam packets?
Spam packets.
Yes, sir.
SPAM.
Yes, sir.
So basically, directly we cannot spam packets. So basically, spam can be done, I think, in application layer. So, so to work with packet, first we have to capture it. So already I have mentioned some of the tools. So like TCP dump, then Warsack. So these are some tools. So using that particular tool from the live network, we have to capture that packet. We have to capture the packet. So another technique is TCP dump, Warsack, then lib pcap, LIB lib pcap. These are some tools through which we will be able to we will be able to capture the packet. And basically we can set some rule on the captured packet, and using that particular rule, basically we can prevent some the network packet, or we can restrict, or we can configure some rule. Are you getting?
Yes, sir. Sir, how are packets related to DDoS attacks?
Okay. So base of service attack is what happens. So see, now you have almost say 200 participants, and I am the speaker. So in this situation, you may assume that I am a server, and you are some node. So ultimately, if all 200 participants ask some question simultaneously to me, I will be unable to give you answer. So ultimately, this is a one kind of DOS attack. That means I will not be available. I will not be able to answer you. So that means no one of you will be able to ask question to me. So in same situation, if we send multiple requests to a server, then server will be not able to answer or respond. So ultimately, if you consider will packet, if multiple packet is transmitted to a server, after some time that particular server will not be able to process that particular packet, and as a result, this will be called a DDoS, denial of service.
Okay, sir, how can we monitor packets and maybe prevent most DDoS attacks?
Yeah, for monitoring, again, we have to use some tool first, and we have to use different network traffic monitoring tool or some capturing tool, and using that particular tool, you have to monitor continuously.
Okay, sir, the next question is by Deep Haloy. What is the role of shift register cascades in cryptography?
Shift register cascade.
Yes,
Shift
sir.
register.
Yes, sir.
So basically, what is register? Basically, shift register. Shift register is basically used to generate some random key. Yeah, basically, register is basically not used for securing. Basically, register mechanism is used for generating some random key or random sequences. So basically, register is capable of holding some bit position. So whenever we need some key in terms of bit, then we can use register. So we may use shift register or any other register for generating random sequences or random key basically. So this is the use of shift register in a cryptography. So this is not basically for securing, this is basically for generating key or random sequences of bit.
Okay, sir. Sir, the next question is from Mayuri Baishya. She has asked, what is quantum cryptography, sir?
Oh, actually, no. Quantum cryptography, right now, actually, I am not able to answer the quantum cryptography.
Okay, sir. Okay, sir. No
Okay,
issues.
basically, in single word, actually, I cannot explain what is quantum cryptography.
Okay, okay, sir. Sir, we have another question from her again. How does the encryption process actually take place?
Actually, in our real life, always we perform encryption. So sometimes what happen? If we say, I am asking, how are you? Using some technique, if I can hide the actual meaning of how are you, that is encryption. So H may be replaced by I. So how? H may be replaced by I, U may be replaced by P, W may be replaced by X. That means how will be replaced by IPX. So that actual text is how, but we have replaced how by IPX. H2W is replaced by IPX. So this is a good example of encryption. But this is a very simple example. We have lots of algorithms through which we can perform encryption.
Okay, sir. So the next question is from Deep Halloy. Sir, how has hash functions are different from public key and secret key cryptography? I guess
Okay.
there are
In
a
case
few
of public
grammatical
key
errors.
cryptography, what happens? Always encryption is done with the help of public key, and decryption is also always done with the secret key. So say if now currently we have 10 participants here. So we all have a public key and we all have a private key. So say Debango has a public key. Debango will share his public key PD, public key of Debango. So in this way, Plavita will share her public key PP, public key of Plavita. And Plavita and Debango will have a private key, and that private key will not be shared with someone else. So whenever I want to send some data to Debango, I will encrypt with the help of public key of Debango. Then only Debango will be able to decrypt the data, since the private key of Debango is with Debango only. And we will perform encryption with the public key of Debango, which is known to all. But private key is only known to Debango only. So whenever we will encrypt some data with the public key and I will share in the group, but Plavita or any other Mayuri or say any other user will not be able to decrypt. Why? Because that is whatever we encrypt with the public key, that is only decryptable by private key of the user. So since I have encrypted the data using the public key of Debango, that particular data is decryptable by private key of Debango only, not by Plavita or me. So public key concept is clear. Then next is private key. In case of private or secret key, what happens? So there will be a secret key, and for encryption and decryption between the sender and the user, receiver, secret key must be shared. Otherwise, no one will be able to encrypt and decrypt. So if I want to perform some secret, if I need to perform some communication, before communication, we should share the secret key. Then only we will be able to encrypt and decrypt. Then hash function is somehow different. Hash function is if you have some plain text data, based on the plain text data, some mathematical or hash function will be performed, and as a result, some value will be generated, and that particular value will be called digest. So say if h is a hash function, so if x is a plain text, so h of x will be some another value. And the beauty of hash function is we can compute from X we can compute HX, that means hash of X. But from the HX we cannot compute X. Are you getting my point? We have a plain text. From the plain text we can generate the digest, but we have the digest. From the digest we cannot get back the plain text.
Yes, sir. Sir, here we have another question. Sir, is cryptography a legal approach? It's a question by Mayuri. Sir, is cryptography a legal approach?
Yeah, definitely cryptography. So basically cryptography is a term derived from cryptology.
Okay.
It's a derived from cryptology. The root word is cryptology. Cryptology has two branches. One is called cryptanalysis and one is cryptography. And basically cryptography is always for good thing. Cryptography is always for making systems secure. And cryptanalysis is opposite. Cryptanalysis always try to how to defeat, and cryptography always try to how to achieve security. So that is why cryptography is 100% legal. Cryptography always try to make the system secure.
Okay.
Okay, sir, the next question is by Nilim S. Bora. How are identities verified in a digital certificate-based authentication system?
So it's simply using digital signature. In the digital signature, so basically digital sign will be put, and where if digital sign is there, then that is we can conclude that we can identify the sign. That means if someone digitally signs, that digital signature gives us the identity of the user.
Sir, the next question is by Mayuri again. When will we use a shrinking generator in cryptography?
Sorry, again, can you repeat?
When will we use a shrinking generator in cryptography?
Shrinking generator.
Yes, sir.
Shrinking generator. SHRI.
NKING GENERAT.
Actually, shrinking generator. I have to see. Shrinking generator. Actually, right now I cannot answer what is shrinking generator. I have to study.
Okay, sir.
Okay, sir.
Okay, sir.
Then is there any valedictory program or
Sorry, sir?
is there any closing ceremony?
Yes, sir. Yes,
Yes,
sir.
sir, we do have.
So at what time?
Sir, now. Immediately.
So who will be joining?
Hiren sir will be joining, sir.
Sir,
Oh, okay. If no one has any question, then we can. So you may contact Hiren sir.
Okay, sir. Okay, sir.
And Moori is from 5th semester?
no, sir, she is from 3rd semester.
3rd semester, okay. Is there any MTech student here? No.
MTech student.
So we are actually streaming it in YouTube, so we don't know their names right
okay.
now.
So it is difficult to identify, okay.
Yes, sir.
Okay, Hiren sir join, okay.
Yes, sir. So with that, we've come to the end of this session of the workshop. We are very grateful to Dr. Satyajit Sarma, sir, for taking out time to conduct this workshop. Thank you so much, sir. Now, we proceed towards the closing ceremony. Now, for this, I would request Professor Hiren Kumar Devasarma, sir, to say a few words to motivate our participants, if possible.
Am I audible?
Yes, sir. Yes, sir.
Oh. So it was really an important event that the Department of IT Guwahati University has conducted. I hope the participants are benefited out of it. And this has given a direction to the students in the line of security engineering which is highly important at this age, where information technology has touched everyone's life, but along with a lot of challenges. It has indeed touched everyone's life, but at the same time, it has posed a lot of challenges in front of everyone. Therefore, having awareness about security and then practicing those safety measures in everyday life is very important. So I hope this workshop has given some directions to the students in which direction they should prepare themselves for the future, and hope they will also help their surroundings, the community in around, in keeping themselves safe in the cyber world. So, with these few words, I wish you all the very best for your future endeavors. And dear participants, I wish you all the very best so that you stay encouraged, you stay inspired, and continue such work tirelessly. You should not get tired. You have to work hard and hard. So there should not be no word like tire in your dictionary. So tireless effort is what is required, and I hope you will do that. Wish you all the best. I thank all the organizers for taking this pain of organizing this particular workshop. At the same time, I also convey my best regards to all the speakers who have spared their valuable time in spite of their busy schedule for the benefit of the students. So, with these few words, I will end my closing talk for the closing ceremony, and stay blessed. Thank you, students.
Thank you so much, sir. Now, I would like to request Abhinash Bordoloi, our team lead, to speak a few words to motivate our participants.
Thank you so much, Plavida. I am audible.
Yes.
So yeah. Good afternoon, respected speakers and our fellow participants. I, Avinash Bordloy, on behalf of the students of the IT Department GU, would like to thank everyone for gracing us with your presence. I would also like to thank all the speakers for joining us and sharing their precious insights on their respective topics. That is Mr. Jayesh Parasar Shah on quantum computing, Professor Hiran Kumar Devasarma on cybersecurity, Professor JP Singh on malware analysis and mitigation techniques, and Professor Satyajit Sarma on network security and its challenges and opportunities. Our special gratitude towards our HOD, Professor Shekhar Kumar Sarma sir, for his support and his guidance. Without him, these workshops would have not been possible. I would also like to thank the workshop chair, including all the faculties of our IT department. I would also like to thank the entire organizing team for organizing and conducting the whole workshop smoothly. This was our first initiative, which was a great success. We will be conducting future events. We have gotten immense support from everyone this time. Similarly, please do support and cooperate us in the future. Once again, thank you everyone for your support and cooperation. With this, I would like to conclude my speech and hand it over to Plavita. Thank you.
Thank you, Abhinash. With that, we have come to the end of our today workshop on cybersecurity, with special emphasis on network security and quantum computing. We extend our sincere gratitude to Professor Shikhar Kumar Sharma sir, Head of the Department of Information Technology, along with all other faculty members of IT Department for helping us in conducting this workshop. We are also very grateful to the guest speakers, Professor Jayesh Parashar sir, Dr. Jyoti Prakash Singh sir, and speakers from our department, Professor Hiren Kumar Deva Sharma sir and Dr. Satyajit Sharma sir. Special thanks to all the participants for cooperating with us in making this workshop a success.
Thank you, everyone. So we will be providing certificates to the participants. Also, special certificates will be awarded to those viewers who were most interactive during the sessions. Thank you all once again for cooperating with us. We'll look forward to many more such workshops in the future. Thank you, everyone. Okay.